This time on Battle Factory, a suit that's tailor-made for the world's most dangerous job. Looking down the barrel of a semi-automatic weapon, a combat-ready boat you can launch from the sky, and a portable missile launcher that's right on target. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When these pieces of hard plastic and bulletproof fabric are molded and stitched together, they'll make a suit of armor that's tailor-made for the most dangerous job in the world. For the bomb disposal specialist, going to work means putting his life on the line. During the Blitz of World War II, the first modern EOD, or Explosive Ordnance Disposal, was established to deal with unexploded German bombs that landed and lodged in London streets. The first operatives worked unprotected, and detonation meant certain death. It wasn't until the 1980s, when British bomb squads were handling IRA explosives, that the protective suit was developed. In combat zones like Afghanistan, where soldiers are more likely to be killed by an IED than by gunfire, bomb disposal specialists are in high demand and at high risk. When a patrol spots something suspicious, the bomb squad is dispatched to investigate, and one operator will suit up and head out alone on what has been referred to as the long walk. The bomb suit is made up of the helmet, the outer shell, the soft armor, and the hard armor. The hard armor is made from a stack of multiple sheets of polyethylene that are placed in a press. Heat, steam, and 1,000 tons of pressure fuse the sheets into a shield that's 10 times stronger than steel and made from the same tightly woven fibers that protect armored cars. Then, the shield is cut into 3 curved plates for each of the body's vital areas: the chest, groin, and the throat. The shield deflects the bomb's high-impact shock waves. Shrapnel has a tough time penetrating the armor. During a tour of duty in Afghanistan, Staff Sergeant Carl Badger Lee's steady hands and cool head have racked up the record for dismantling twice as many IEDs as anybody else. He's defused 139 bombs, 42 of them in one village alone. In 2010, Badger was awarded a medal for his acts of bravery by Prince Charles. He also saved thousands of lives. While the hard armor protects against a worst-case scenario, when you're picking up bombs, you still have to be able to move. So the bulk of the bomb suit is made from flexible, soft armor that bends and stretches with the wearer. Sheets of bulletproof synthetic material called Aramid are rolled onto the cutting table. Patterned stencils are laid over the material, traced and cut. When a bullet or shrapnel connects, the fabric softens the blow by catching it in the tight-knit weave, like a spider web, and spreading the impact across the material. The bomb suit helmet starts as rectangular pieces of ballistic material, which are forced into a rounded steel mold. A heat-resistant balloon is dropped into the mold and connected to an air supply. The balloon is inflated, and the mold is placed in a kiln. The pressure and heat of the kiln shape the helmet. Once the shell is baked, the balloon is deflated and removed. The helmet is cut into shape with a handsaw. The surface is sprayed and baked to a hard glaze. The hard and soft armor are stuffed into the outer shell, and the helmet is fitted with accessories like lights, a communication system, and a protective visor. After 40 hours of careful craftsmanship, this bomb suit is complete and ready to be tested. Even though a sample from each batch is put through rigorous testing, wearing a bomb suit does not guarantee you won't get hurt. But if you dismantle bombs for a living, you want your work clothes to give you a fighting chance and make the most dangerous job in the world a little less dangerous. Coming up on Battle Factory, the business end of a C7 rifle, and an inflatable boat that can take a bullet without sinking. What starts off as a 7-pound bar of steel will soon deliver a bullet with deadly accuracy. The barrel of a Colt C7 assault rifle. In the Gulf War, Rwanda, and Afghanistan, the Colt C7 has served as the standard-issued weapon to soldiers around the world. And a rifle's ability to shoot straight and aim true is built right into the barrel. Cylinders of high-carbon tooled steel move along a conveyor belt to a machine which can precision drill the 10-millimeter holes in up to 4 barrels at a time. It takes about 10 minutes for the carbide bit to drill through the bar. Every barrel is checked by hand to make sure the bore is clean. The C7 fires 15 rounds per second at speeds of over 3,500 kilometers an hour and has an effective range of up to 620 meters. Even the tiniest scrap of dirt could throw a bullet off its target and make the rifle dangerous to fire. Bosnia, 1993, was the first time that the C7 saw action, and it was an historic battle. Canadian peacekeepers were forced to draw their C7s to defend their position, a civilian village against a hostile military invasion. They were outnumbered, but not outgunned. In what was considered one of the most severe battles since the Korean War, the Canadian forces, armed with C7s, managed to defeat their adversaries. A robotic arm sends each barrel into the hammer forge. 4 synchronized hammers pound on the bar, which shrinks the bore diameter, stretches the barrel, and toughens the steel. Meanwhile, the barrel is squeezed around a spiral-shaped tool that forms the rifling, a unique corkscrew design on the inside of the barrel. These grooves in the barrel cause the bullet to spin and fly straight. They also etch a ballistic fingerprint in every bullet that'll match the gun it was fired from. Coming out of the hammer forge, the barrel has grown 20 centimeters. A technician inspects the barrel's interior, checking the grooves that make up this rifle's fingerprint. The barrel is dropped into a 1.8-meter deep firing pit, and a single high-pressure test bullet is fired. This determines if the explosive impact will cause any damage to the barrel. The barrel is soaked with oil containing fluorescent iron particles. Then it's run through a magnetic particle inspector to check for flaws. An electric current makes any crack in the barrel magnetic. The iron particles accumulate around even the tiniest flaw, which is visible under black light. Less than 1 in 100,000 barrels are found to be defective, but this test is critical. After a month's worth of work, the test discovers a crack barely a fraction of an inch long. The barrel is rejected. A fracture might lead to the rifle literally blowing up in the shooter's face. In Bosnia in 1993, Canadian forces were in their first major gunfight in almost 40 years. But with the help of the C7 assault rifle, they redefined what peacekeepers can do, and thousands of lives were saved. After meeting the demanding standards of the C-Series assault rifle, the rest of the barrel is assembled. Once the barrel is complete, it's hammered onto the stock. The C7 assault rifle is an extension of every soldier on the ground. The barrel is a critical extension of the C7. The action loads and fires the ammunition, but where that bullet is headed depends on the barrel. Coming up on Battle Factory, a boat that can take 20-foot waves, enemy fire, and still stay afloat. And lightweight artillery that packs a heavy punch. This sharp-edged wedge of steel is built to cut through and rise above just about anything the ocean can throw at it. From police operations to amphibious assaults, the Zodiac Hurricane is the go-to vessel for deploying Marines, Navy SEALs, and Special Forces around the world. Whether it's launched by land, aircraft, or off the deck of a ship, this boat is virtually unsinkable. The Zodiac Hurricane breaks down into 3 parts: an air-filled rubber collar, the crew compartment, and an aluminum hull. The first step in construction is building the hull. 1-meter pieces of lightweight aluminum are welded together to form the 9-meter structure. The bulkheads are then lowered onto the hull and hammered into place to provide structure for the frame. Then they're welded together. The welds are ground down to a smooth finish. The hull's deep V shape minimizes resistance, which increases speed and stability. The Hurricane's got a step system across the bottom and the rear sections of the hull. This air-channeled system reduces surface contact with the water, which makes for faster acceleration and better handling. That speed and agility made the Zodiac Hurricane a key player in 2009's Operation Atalanta. In the Indian Ocean off the coast of Somalia, an EU Navy ship lured pirates out to sea by posing as a merchant vessel that was vulnerable to attack. When the pirates got close, the Navy turned about and launched a coordinated attack of high-speed Zodiac Hurricanes and helicopters to take down the pirate ship and bring the raiders to justice. When you take a wave at 50 knots, the Zodiac Hurricane hits the surface with bone-crunching impact. But on board, the passengers are cushioned from the blow. Once the seats are assembled, testing can begin. The seats are tested for strength and durability. They're mounted on a miniature V-shaped hull. Sand stands in for water. The rig simulates a 136-kilogram passenger hitting the water with 3 Gs of force, enough impact to knock a person out or even kill them. If they can take the hit, the seats are installed. The final step in the assembly is the inflatable neoprene collar. It's what makes a Zodiac a true Zodiac. The collar stabilizes the boat in rough water and acts as a shock absorber to reduce the bounce in the ride. The collar is manufactured from neoprene rubber, which is rolled out, measured, and cut. The pieces are carefully glued together using a heavy-duty cement to make sure the tube is watertight. And once the cement is dry, the collar is inflated and double-checked for air leaks. In a skirmish, the collar's outer layer of hard foam is designed to absorb a spray of bullets. But if one gets through, the collar has 5 separate air chambers, so it can take a hit and still stay afloat. Before installation, the collar is deflated. The collar is then slid on and fastened to the hull.
1, 2, 3.
Whether it's a high-speed pursuit, onboard assault, or anti-piracy operation, the Zodiac Hurricane is equipped for combat. Coming up on Battle Factory, it takes seconds to put together and can drop a shell 6 clicks past enemy lines. Once these steel tubes are honed, they'll become portable missile launchers. An infantry weapon that's highly effective and deadly simple. The M252 81mm mortar can trace its roots back to the Stokes mortar, first used in World War I. This lightweight muzzle-loading artillery fired explosives that could arc over enemy barricades and land in the trenches. First introduced by the British in 1915, it soon became the most widely used mortar among the Allied armies. The modern-day M252 mortar assembles in seconds, can be transported over any terrain, and drops 15 rounds per minute with a range of almost 6 kilometers. The M252 mortar breaks down into 3 components: the cannon, the mount, and the base plate. The base plate starts out in a cutting-edge machining center and is milled to be both sturdy and lightweight. It's showered in coolant to reduce friction and heat. And when it's finished, it will only weigh 13 kilos. The base plate stabilizes the mortar so it can fire accurately no matter where it's set up. It also absorbs the recoil that would otherwise drive the cannon into the ground. The base plate and the rest of the rig have to be lightweight enough so that once rounds have been fired, the mortar can be moved out fast. The core of the mortar is the steel cannon that launches the shells. When a shell is dropped into the mortar, a primer connects with the firing pin and ignites the propellant, which creates the explosion that launches the shell from the cannon. The bottom of the cannon is etched with cooling fins. With a round firing every 4 seconds, the mortar cannon gets red hot. Cooling fins are grooves that expand the surface area and draw the heat away from the barrel wall, making it possible to keep firing the mortar. But mortars aren't used solely for warfare. Sometimes they're used to trigger mini avalanches. These precisely controlled explosions loosen the snowpack before they can build up into major avalanches that would block the nearby highways and put people in danger. The mount on the mortar serves triple duty. It stabilizes the cannon, helps absorb the force of the blast, and can adjust the angle for aim. The mount's shock absorber uses springs to dampen the mortar fire's recoil. Once the mount is assembled, a hand crank can adjust the angle. During a mortar operation, every second is critical. On the front lines, mortar teams use this lightweight, compact weapon system to support infantry and penetrate enemy blockades. And like the mortar itself, the team is a synchronized unit acting as one to achieve maximum impact and maximum effect. This time, on Battle Factory, a personal flying machine that takes surveillance to new heights. A GI jacket that blends into the background. An army base you can pack on a truck and drop on the front line. And an all-terrain vehicle that never touches the ground. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this piece of lightweight aluminum is cut and tooled, it will become the frame of a personal flying machine. Strap on the Parajet, take off from just about anywhere, and soar to an altitude of 3 kilometers. Used by military operatives, drug enforcement agents, and first responders, it gets you in and out fast, whether you're carrying a camera or a gun. Since implementing the Parajet, flying cops of Florida's Palm Bay Police Department are now able to spot stolen vehicles and locate marijuana grow fields from the sky. The Parajet breaks down into the engine, the wing, and the airframe. The first step in making the airframe is to machine the base plate. It's made from super strong aircraft-grade aluminum. This is the heart of the airframe that will hold the engine and gas tank on one side and the harness on the other. As the computer-controlled cutting machine carves out the base plate's holes and contours, it is soaked with a coolant that lubricates the tool and keeps it from overheating. Holes are machined out of the aluminum to make the airframe even more lightweight. The same process is applied to all other parts of the airframe, including the pivot arms. The pivot arms are what connect the base plate and the flyer to the wing. They control direction either by hand or by shifting weight in the harness, leaving the pilot's hands free to hold a weapon, a medical kit, or a camera. The Parajet is designed to snap together quickly in the field without tools, so every part is machined and measured down to the fraction of a millimeter. This fit has to be perfect to withstand wind and engine vibration. It can't come apart at 3 kilometers in the air. Once the metal pieces have been cleaned and measured, they're shipped off-site to be treated for strength and weatherproofing. The freshly treated parts are returned to the shop floor, and assembly of the airframe can begin. First, 6 spars are clipped to the base plate to form the framework. Curved aluminum completes the cage, which protects the pilot from the propeller blades. A fuel tank is hung on the base plate, which will last for 3 hours of flying. Netting forms a barrier between the flyer's arms and the blades. Finally, the 27 horsepower engine is mounted to the base plate. If the wind is right, the Parajet can carry a flyer at top speeds of 65 kilometers an hour. Next, it's time to connect the harness. The harness attaches the Parajet to the pilot. It gets snapped onto the base plate and bolted to the pivot arms. The propeller is made of 2 lightweight carbon fiber blades. They're fitted together and bolted to the engine. Before the Parajet can take to the air, it has to go through a hang test. This is to ensure it can hold the weight of a pilot. The Parajet is strapped on and clipped to a parallel bar. The suspended tester shifts and stresses the harness to make sure everything is holding tight and secure. The engine is revved to the red line, around 7,500 RPMs, to make sure the engine is putting out enough power without shaking loose the frame. Having passed the factory trials with flying colors, the Parajet is ready for a sky test. The device breaks down into mission-ready components. In the field, it's reassembled in 5 to 10 minutes. The flyer pulls the starter to get the motor running. Using Kevlar core lines, the flyer connects his harness to the Parajet's wing. It's made of the same ripstop polyester fabric that parachutes are made of. The flyer runs against the wind and takes a flying leap. The test pilot puts the Parajet through demanding maneuvers, banking and diving, and turning the craft by pulling the hand toggles to steer. It is capable of precision flying, multi-range destinations, and can carry up to 280 kilos of pilot and payload. So whether the mission is bringing back intel, getting a bead on contraband, or locating a victim in harsh terrain, the Parajet turns the well-trained pilot into a spy in the sky. And once you see the Parajet suspended in the clouds, you will believe a man can fly. Coming up on Battle Factory, a camouflage jacket that disappears in the dark, and a portable army base that's combat ready in under an hour. This camouflage print was digitally designed under the supervision of the Canadian military's Department of Defense. Then the material is brought here and tailored into a soldier's most versatile action wear, the camo jacket. CADPAT, which stands for Canadian Disruptive Pattern, is the latest in camouflage combat wear. It's made to look good while not being seen. Uniforms were originally made with bold colors, so soldiers were easy to identify in a cloud of artillery smoke. It also made them easy targets. By World War II, GIs were wearing camo, like the American frog skin and the British brushstroke pattern. The CADPAT jacket also camouflages the wearer at night by masking his infrared signature. A classified formula in the dye makes the jacket almost undetectable to night vision scopes. It takes 54 individual pieces of rugged textile to form the jacket, and it will be worn from basic training to the combat zone. The jackets are constructed from 152 centimeter rolls of CAD-PAT material. A computer-generated pattern for the jacket is printed on a roll of paper that matches the width of the fabric. The paper is rolled out over 200 layers of material, a template of all the pieces required to make the jacket. A razor-sharp blade cuts through all 200 layers at the same time. The pattern's been laid out to maximize the material, so there's very little waste. The 54 individual pieces are ready to be assembled. At the sewing station, it takes 42 people almost 2 solid hours to put the jacket together. The jacket is sewn tough and built to last, with reinforced seams and strong plastic thread. There are CAD-PAT jackets still in active duty 2 decades after they were issued. Once complete, every jacket gets a careful inspection, testing the Velcro fastenings and pocket strength. Recruits only get 4 changes of uniform for their entire tour of duty, so durability is critical. 1 button out of place, and it doesn't make the cut. As a security measure, every CAD-PAT jacket gets its own serial number. That way, each and every uniform is accounted for. If it wasn't assigned to you, wearing this jacket is against the law. The CAD-PAT jacket is tested by soldiers for soldiers. On the training field, they'll make recommendations to improve comfort and utility that are incorporated into the new design. Vents along the back and elastic around the torso allow for easy movement. The high-color, indestructible buttons and non-reflective zippers seal the jacket around the wearer and insulate the soldier against the elements. Once it's issued to a recruit, the CAD-PAT jacket will do double duty as training gear and combat uniform. Whether they're shipped out to Kosovo or Kandahar, the uniform will last for as long as the soldier's term of service. And that jacket won't just keep the soldier warm and dry, it'll help keep him alive. Coming up on Battle Factory, no matter where the fight takes you, you've got an Army base in a box. And no matter what the terrain, this craft will get you there. These boxes may look like standard storage containers, but these stackable, shippable units can travel to combat zones anywhere on Earth. And in 30 minutes, they can unfold into a fully equipped military facility. They can be customized into command posts or science labs, hospitals or barracks. These mobile military shelters can create a working Army base in the middle of nowhere in a matter of hours. Each unit breaks down into 2 parts: a rugged metal container and high-tech tenting that can expand into 27 different workspaces and living areas. The mobile military shelter starts out looking like a standard steel shipping container, but it's about to be equipped with everything you need to make it practical and comfortable, starting with insulation. Every surface is coated with a heavy-duty foam insulation. It's mixed with a chemical called cyanide, so it hardens quickly. Cyanide is highly toxic, so the area is restricted to workers wearing safety masks. Once the insulation is complete, each of the 2,600 parts, including locks, frames, and handles, are painted military green. This reduces the unit's infrared signature, making it tougher to detect. The doors are insulated with rubber weather stripping to protect against extreme conditions. Whether it's 50 above or 50 below, the weather outside stays outside. Next, the container is fitted with wiring to power up everything from radars to microwave ovens. The unit's generator can run enough air conditioning to cool a 3-bedroom house. A fresh air intake keeps the atmosphere inside comfortable. One tank of diesel can put out enough power to charge 2,600 smartphones. Once the unit is assembled and wired, it's ready for testing. It has to be able to weather any storm, so it's put through a high-pressure hose down on all the joints and seals. If it can't handle the outside, they don't start work with the inside. When the Canadian Department of Defense needed to keep warm in the Arctic, a Hercules transport plane airdropped instant shelter onto the sea ice, 80 kilometers north of the most northern landmass on Earth. Once it's passed the water test, the unit is ready for tenting. The exterior metal walls drop down to form the expanded floor, and the built-in tenting material forms the walls. A wafer of high-tech bubble wrap is sandwiched between 2 layers of PVC. This insulates the tenting against Arctic chill and desert heat. The tenting is unrolled and support rods are installed. The expanded unit builds out to 37 square meters of modular floor space. It can be outfitted to any one of 27 different units, including satellite imaging center with radar system tracking device, vehicle repair depot equipped with hydraulic lifts, or a field hospital complete with exam tables and medical equipment. To make the unit transport ready, furniture and gear are locked snugly into the middle of the container. The finished container is secured to the back of a military vehicle and test-driven, hitting the road hard to simulate rough transit. After the shakedown, the unit is parked. The walls come down and the tenting goes up. Every piece of gear is put in place and tested to make sure that when this mobile military shelter is deployed, it will do what it's supposed to do where it really counts, in the combat zone. Coming up on Battle Factory. When you need to get over land and sea and snow and swamps, this ride feels like you're floating on air. Because you are. When these PVC panels are filled with air, they can transform a boat into a hovercraft. The hovercraft is a hybrid vehicle. Propelled by air, they can float on water, land, ice, or sand, which makes it the perfect vehicle for troop carriers, amphibious assault, and search and rescue. So when an F-16 went down in Utah's Great Salt Lake mudflats, hovercrafts raced to the scene over land and water and were able to reach the pilot in time to carry him to safety and recover sensitive cargo at the crash site. The hovercraft is made of a cab, skirt, propeller system, and an inflatable hull. The high-strength PVC hull has 5 separate buoyancy chambers. Even if 3 of them lose pressure, the hull will still stay afloat. Once the hull is inflated, The frame is lowered onto it. The hull is treated with marine-grade silicone to make sure it slides on smoothly. Then the frame is bolted into place. The skirt is what makes the hovercraft hover. When air is fanned under the hull, it's trapped in the skirt. When the pressurized air exceeds the weight of the craft, it starts floating on that cushion of air, which means the hovercraft can go just about anywhere. To make the skirt, heavy gauge PVC is rolled out onto a table. Using a grease pencil, the pattern is traced and cut. Every piece is made to measure. Heat-activated glue is brushed onto the strips, which are stretched over a skirt-shaped wooden template. Once all the panels have been joined together, the horseshoe-shaped skirt is ready to attach to the hull. The underside has been brushed with adhesive, and the completed skirt is pressed onto the hull. Then it's hoisted and flipped, and the skirt is wrapped around the hull and heat-sealed tight. Then, 16 hollow rubber panels, or fingers, are zip-tied to the bow. When the skirt is filled with air, the fingers create an impact-absorbing curtain around the nose of the craft, which makes for a smoother ride in rough water. If the fingers get damaged, they can easily be replaced or reattached in minutes. The hovercraft is equipped with a variable pitch propeller system. Gimbals on every blade enables the propeller to pivot and rotate on its axis, and gives the hovercraft the ability to brake and glide in reverse. Rotating the propeller on a spindle, the tech checks that all the blades are weighted exactly equally, adding a washer if a blade is even the tiniest bit out. A misaligned propeller will cause major vibrations when spinning at top speed. Once complete, the propeller is mounted in the cage to protect it from getting clogged with bits of debris. 3 rudders are fastened behind the propellers, which directs the airflow and steers the hovercraft, not unlike a helicopter. Finally, the fiberglass cab and seats are dropped into the frame and bolted in. The dashboard containing speedometer and pressure gauges, throttle, and steering systems are installed. The hovercraft is good to go, ready to glide over land and water. With its wide skirt and low center of gravity, the hovercraft is almost unsinkable, even at top speeds of 100 kilometers an hour. Part boat, part airship, all terrain, the hovercraft is mission ready, no matter where that mission takes it. This time on Battle Factory, a sharp-looking weapon that's been a cut above since World War II. When you need to get 250 tons in the air, it's the only way to fly. Aiming for an enemy that's 2 kilometers away. And a mini-bomb that fights fire with fire. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When pounded with 100 tons of force, This sheet of steel will produce a blade that's honed by old-world craft and cutting-edge technology, and make an iconic knife that's as versatile as it is lethal. The K-Bar fighting and utility knife first saw action in 1942, when it was issued to the U.S. Marine Corps during World War II. Originally intended for hand-to-hand combat and basic needs, soldiers soon found that they were using the knife to defuse landmines, dig foxholes, as bayonets on rifles, and to open ammunition containers. For 70 years, it's been the favorite combat and utility weapon for service men and women. The knife is made up of a leather-crafted handle and a razor-sharp blade of tempered steel. The first step in making the knife is to take a sheet of steel called chrome vanadium and coat it with oil so it won't rust. Then, the 100-ton press punches out the blade. This kind of metal, used exclusively by K-Bar, is flexible and easy to sharpen. The added chrome makes it tough. The next step is stamping. Both the logo and the signature groove are stamped into the knife. This channel is called a blood groove, designed to make it easier to pull the knife from its target. Once they've been stamped, the blades move through a flat grinder. The blade is tapered towards the tip, creating a double edge, which gives the knife its signature look. The handle of the K-Bar knife is made up of leather washers. The washers are stacked tight onto the blade handle with a compressor. Then, all the leather pieces are hammered into place and capped. The cap is then secured with a steel pin, so the new leather handle is kept tightly in place. Next, a sander cuts deep grooves into the leather and smooths and tapers the handle for a better grip. Now, the handle is ready for painting. A brick of wax is loaded into the machine, and the leather rotates around it. The wax protects the handle against wear and moisture. Then, the grooves are colored with a black dye, which soaks easily into the leather. And the handle is complete. Each side of the cutting edge is sharpened by hand to exactly a 20-degree angle. Any thicker, and the knife will be dull. Any thinner, and the blade won't last. A skill that takes a master craftsman years to perfect. Finally, the blade is polished against a cotton wheel. This buffs the metal and removes any imperfections left on the blade. Once polished, the master craftsman takes each blade and slices it through a piece of paper. If the knife is too dull, the paper will crumple, but if it slices cleanly, it's ready for testing. First, a laser beam measures the angles of the cutting edge. If it's 1 degree off the 20-degree sweet spot, it goes back for resharpening. If the angle is accurate, the blade must pass the rope test. If it can't get through a piece of nylon rope in 2 slices, it doesn't make the cut. Then the knife is checked for imperfections. Even the smallest flaw means it's sent back for refinishing, or ends up opening boxes on the factory floor. Once the knife has passed inspection, it's boxed up and shipped out for active duty. The K-Bar knife has served alongside generations of fighting men and women. Whether it was close-quarter combat or opening a can of rations, the K-Bar was built to give a soldier the edge. Coming up on Battle Factory. This high-tech transport weighs 65 tons, and it's lighter than air. And a sniper's bullet that travels 3 long seconds to connect to its target. When these aluminum struts are joined together, they'll make up the shell of an airship that's never been seen in the sky before. Aeroscraft is the first of its kind, a 21st century take on the Zeppelin airship that has been part of flying tradition since the 1900s. Zeppelins of the day were originally designed as passenger ships and couldn't lift much cargo, and they were powered by highly flammable hydrogen gas. The Aeroscraft might look similar, but this military-funded prototype could revolutionize cargo and personnel transport. Airships of the future will be able to carry up to 250 tons of cargo and be able to take off and land vertically on any terrain with no need for a runway or ground personnel, making them the perfect transport system for bringing aid to ground zero in the aftermath of an earthquake or a hurricane. It took 10 years and $35 million to get the Dragon Dream prototype this far. But before it can go into full production, this experiment has to prove it can get off the ground. The Aeroscraft is made up of the helium buoyancy system, the aeroshell, the control center, and a rigid structure. The rigid structure is the skeleton of the Aeroscraft. It's made of lightweight aluminum and carbon fiber, strong enough to carry heavy loads and light enough for flight. Creating the trusses is like erecting a bridge. There are over 200 of them, ranging in length from 6 to 18 meters, and each truss has to be welded to the next by hand. It's taken 50 people 3 years to finally put together the form that creates the floor, the ceiling, and the cargo compartment. It's designed to be strong enough to support the propulsion system, the cockpit, and the helium containers. Helium gas is what makes the Aeroscraft lighter than air. In the past, the original airships would rise with the help of a lifting gas, hydrogen, and by dropping ballast, water. However, hydrogen is highly flammable, and an accidental spark could end in disaster, as it did with the infamous Hindenburg in 1937. Helium, which is not flammable, powers the Aeroscraft's groundbreaking variable buoyancy system. This enables it to move up and down like a submarine without taking on ballast. Simply adding compressed air from the surrounding atmosphere puts the helium under pressure, which reduces lift so the craft drops. Release the air, the helium expands, and the craft rises. So the first step in creating the buoyancy system is to make the large helium container. Made with lightweight plastic, filled with helium, and stored in the upper trusses of the ship's fuselage. It takes over 10,000 aluminum struts to make the outer shell. Wafers of honeycombed aluminum are sandwiched between each of the struts, and holes are punched out to make the aerodynamic frame even lighter. Once the shell is built, the next step is to cover it with a fabric skin made of mylar and carbon fiber. The skin is designed to deflect the heat of the sun away from the helium. Too much heat expands the gas and makes the ship harder to control. Once the exterior is complete, the glass cockpit, which includes seats and a touchscreen control panel, is suspended from the bottom of the ship. The aerocraft is steered by a rudder and powered by 3 engines which rotate on their bases for maximum maneuverability. The engines, wings, and the rudder are installed. After 5 years and $35 million, all the pieces of the Dragon Dream prototype are installed and ready for testing. Computer simulations can only predict so much. It all comes down to this moment. If this scale model gets off the ground, it will give the company the real-world results it needs to take production to the next level. A fleet of lighter-than-air aircraft that will be able to land anywhere on Earth and unload enough military force to protect a city, or enough humanitarian aid to feed one.
5, 4, 3, 2, 1, 0. All engines running.
Liftoff. While the aerocraft's maiden voyage only goes about 15 meters off the ground, the prototype's test flight was a success. Expectations are high. Now, the real work can begin. Coming up on Battle Factory, how to take down a target 2 kilometers away, and a plastic egg that's harmless until it hatches fire. In 48 hours, this harmless block of metal will be formed into the most accurate weapon on Earth. The AX-338 sniper rifle. Its predecessor, the AW-338, holds the record for the longest confirmed combat kill in recorded history. In Afghanistan in 2009, it was used to hit a target from 2.4 kilometers away. The AX-338 breaks down into 4 main parts: the magazine, the barrel, and the chassis and action. The chassis and action are the guts of the gun. Together they hold, feed, and fire the ammunition. The chassis is cut from a solid block of aluminum on a CNC machine, a computer-controlled cutting machine that ensures accuracy to the 10th of a millimeter. A coolant spray reduces friction and overheating. What makes this gun so accurate is that the chassis and the action are locked solid. There's never any movement between them, not even when the gun is being transported, and especially when the gun is fired. In long-range operations, even a microscopic shift means missing the target by several meters. Using the same process, the action is cut from a block of steel. The action and chassis are set aside in order to make the hinge. The hinge connects the butt of the gun to the chassis. It's made of 2 pieces of solid aluminum that join together perfectly. Once the hinge is locked in place, it doesn't budge. But when unlocked, it shortens the length of the rifle by 25 centimeters. In combat, the enemy is always on the lookout for the sniper whose longer rifle can give him away. But the ability to shorten the gun means the sniper now blends in with the other soldiers and avoids becoming a target himself. The mounting tube is an innovation developed to fasten night vision, lasers, and other accessories to the barrel. It starts as an aluminum cylinder. It is milled into an 8-sided shape with over 100 key slots drilled into its sides. The attachments hang off the slots. The mounting tube is free-floating, designed to fit over the barrel without touching it. That way, the weight of the attachments won't put the barrel off balance and affect the aim. The precision-designed barrel is 68.58 centimeters long and rifled with unique grooves on the inside wall that cause the bullet to spin and fly straight. When the bullet leaves this barrel, it'll be traveling at more than twice the speed of sound. In the record hit of 2009, the sniper's bullet took 3 seconds to travel 2.4 kilometers, or 20 city blocks, to connect to its target. For its final exam, the rifle is calibrated for 100 meters. Five shots are fired into the target. Every shot must land within this 3.5 centimeter diameter for the rifle to be deemed battle-ready. In a war zone, police standoff, or hostage-taking, the sniper is often the only solution to a bad situation. And if a target is caught in the crosshairs of an AX-338, from 20 city blocks away, he'll never know what hit him. Coming up on Battle Factory, little plastic eggs that can burn a forest to the ground. These colorful plastic eggs may look harmless, but they're actually little time bombs that can set a forest floor ablaze in under a minute. Dragon eggs are mini missiles that are launched from a gas-powered cannon. 20 seconds later, the egg ignites to spark a strategic blaze from a safe distance. Firefighters use the combustible eggs to stop wildfires in their tracks by cutting off their fuel supply, fighting fire with fire. The Green Dragon launcher is made up of 3 parts: the chemical injection system, the launcher, and the eggs. The incendiary eggs are made up of 2 halves of a plastic sphere that's 3 centimeters in diameter. The egg is fueled with crystals of potassium permanganate, a chemical that on its own is harmless, stable, and non-combustible. Until you inject them with antifreeze or glycol, which, in 20 seconds, results in a volatile exothermic reaction that flares at over 2,200 degrees Celsius, causing enough firepower to set even wet wooded areas aflame. About 10,000 of these harmless-looking eggs are produced in a single shift. Enough firepower to burn 60,000 hectares. Agencies across North America and Australia will order over 2 million eggs in a year to control wildfires. The launcher contains 200 parts and takes almost 8 hours to assemble. With only 20 seconds between injection and ignition, the launcher's got to work perfectly or the whole system can backfire. The launch mechanism incorporates a 4-cycle system that moves the egg into the chamber, injects it with glycol, drops it into the barrel, then launches it on a blast of air. In Bosnia in 2012, Dragon eggs were fired from the turret of a tank to clear overgrown minefields almost 20 years after the conflict. On the firing range, the glycol reservoir is filled up, and up to 450 Dragon eggs are dropped into the hopper. The Green Dragon is armed and ready to deploy. Dragon eggs can be launched from a moving vehicle or dropped from the sky. The eggs are launched 40 times a minute and need to travel up to 60 meters in order to keep people out of the hot zone. The chemical reaction starts in the air, but doesn't fully ignite until the 20-second mark, once the innocent-looking egg hits the ground a safe distance from the cannon and the operators. This little plastic sphere may look like a child's toy, but when armed, it has the power to starve a wildfire or clear an overgrown battlefield. This time on Battle Factory, this lifesaver rolls into the danger zone to neutralize a bomb. A transport vehicle that's battle-ready anywhere, even underwater. And if you have to bail out at 30,000 feet, this life raft could mean you'll live to tell the tale. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this piece of aluminum is welded and wired, it will become a robotic arm that can punch through walls, look for suspicious objects, and carry deadly explosives safely beyond the blast zone. Employed by military and police security forces, the robot can go where people shouldn't, to seek out and extract explosive devices for safe detonation. In the chaos of 2013's Boston Marathon bombings, robots played a critical role in preventing further casualties and in the apprehension of the bombers. The robot, named the WM Knight, is made up of the arm, the hazard probe, and the chassis. The chassis is the guts of the robot and what gets it from A to B. It's made from sheets of lightweight aluminum, and each part is cut using a water jet. Water and sand combine under very high pressure to make a precision blade that slices through the metal like butter. Then, the sheet is bent under 88 tons of pressure to form the chassis frame. Once formed and machined, the chassis is sent to a paint booth. The aluminum walls and the air gun are wired with opposite electric charges, which attract, so the thick coat of powdered paint magnetically sticks to the surface. This powder coating is tougher and more durable than a standard paint job. Next, the wheelbases are installed. Then, the gear-driven chain pulleys. Two motors, controlled independently, drive one track forward and the other one backwards to maneuver the robot around corners. The first ever bomb robot was invented in 1972 after 8 British soldiers were killed by IRA bombs in less than a year. A lawnmower was jerry-rigged with a remote control to make the first primitive bomb robot. It's since evolved into a critical life-saving member of every bomb squad. Today's Knight robot comes a long way from the lawnmower. The tires are mounted and encased in a track that will keep them rolling together. This design allows the robot to travel over rough terrain, including deep snow, and even up and down stairs. The arm is cut from aluminum using the same water jet process as the chassis. Then, it's welded together and painted. The arm of the bomb robot is designed to move like the human arm. Its aluminum shoulder, elbow, and wrist move independently. It's strong enough to lift 113 kilograms, and its unique hand grip is precise enough to pick up a paper cup without crushing it. The secret to the precision is in its gearboxes. Each one is outfitted with a complex gear system, allowing the joints to move in multiple directions. The arm's cables, made of copper wires, are the nerves and tendons that connect it to the operator. The cables are threaded into the arm's aluminum skeleton, and the arm is now operational. Kitted out with lights, camera, and an infrared scope, the arm can extend 3 meters in the air to access hard-to-reach spots. And it can be controlled remotely to keep humans out of jeopardy. In the manhunt following the Boston bombings, when the killer was finally found, it was a robot who pulled back the canvas tarp to find him hiding in the bottom of a boat. The HAZ probe, short for Hazard Probe, enables the robot to break through hard surfaces and uses a camera to see what's beyond them. Under the hood of the HAZ probe is an 18-volt motor that powers the drill. It can be outfitted with any number of drill bits, depending on the material it has to get through. Once the hole's been cut, the drill bit pops off, making way for the camera. It can see beyond a wall or even into a suspect vehicle, giving the robotic arm the upper hand. Before the bomb robot can be put into the field, it runs a complete simulation. A gas tank is used in place of a bomb. For this test, the robot has been fitted with a small ramrod designed to break through glass. The arm reaches through the shattered window and lifts the tank out of the car and carries it off for safe disposal. With so many soldiers losing limbs and lives to IEDs, over 3,500 bomb robots have been deployed to Afghanistan. And to date, over 750 of them have been destroyed. But for every robot lost, human lives were saved. Coming up on Battle Factory. If you're lost at sea, this raft can buy you the time you need until help arrives. And a bulletproof, waterproof carrier that can track any terrain to bring personnel to the front line. It will take days for these rolls of watertight fabric to be cut and sewn and fused together. And 7 seconds to put to work. 7 seconds that may make the difference between survival and never making it out of the water. In October of 2011, a search and rescue team of 3 was parachuted into Arctic waters to rescue men trapped in the ice. When their plane had to return to base on account of weather, the rescue team became the victims. After 5 hours in the icy water, 2 of the 3 men survived by waiting in their personal life rafts. The single-person life raft is designed to be stowed in the cockpit of fighter planes. If the pilot ejects over open water, the life raft goes with him. The single-person life raft can be broken down into 3 parts: the hull, the floor, and the canopy. Sheets of bright orange fabric are rolled out. The color has been chosen so the canopy can easily be seen from the sky. Guided by a computer-generated stencil, the electronic cutting station tracks the program measurements, marks the pattern on the fabric, and cuts it out. At the sewing station, Velcro trim is attached to the edge so it can be closed around the body. Velcro is flexible and can withstand the high-pressure vacuum packing required for the ejection seat. A zipper would get crushed. If you're bailing out of a fighter jet, help may be on the way. But if you go down in icy water, death by hypothermia can occur in a matter of hours. This canopy can make the difference between life and death while waiting for help to arrive. The floor is made up of 2 layers of specialized nylon. The first layer is brushed with glue, and dimple patches are pressed into the pre-marked spots. When the floor is inflated with an onboard tube, the dimple patches create a quilted pattern of air pockets, which insulates the survivor from the chilling water. When the raft is assembled, it has to be watertight and maintain its buoyancy. The superglue that does this is made by mixing neoprene and a chemical activator. The glue is mixed daily, and every batch is tested. The bond has to withstand at least 5 pounds of force. If the glue doesn't make the grade, any rafts made with the batch are rejected. Next, high-resistance nylon cord will be placed into the floor to assist in inflation. The cord provides a pathway for the gaps between the layers of compressed nylon. Another cord connects the sea anchor known as a drogue, which slows and stabilizes the raft in high seas. While the stranded search team waited for help in their protective canopies, their life raft's anchor also kept them from drifting off course and being lost at sea. The 2 layers of floor are attached, leaving a tube exposed that will be used for inflation. A rubber inner tube is inflated and attached to the floor of the canopy. While the top of the raft is orange for visibility, the bottom is black, making the life raft less visible to sharks. Next, the rapid inflation system is installed. Each raft is fitted with a carbon dioxide cartridge hooked up to the valve on the side of the hull. It'll be used to inflate the raft once it hits the water. Now, the raft is ready to be tested. When it's folded up tightly, it'll be small enough to be fitted in an ejection seat. And in the event of an emergency bailout, it'll be ready to deploy in 7 seconds flat. The single-person life raft is ready for duty. And if you're using it, you're probably having the worst day of your life. But now there's a chance you get to see tomorrow. Coming up on Battle Factory, an armored amphibian that will take the troops to the front and back in one piece. When this steel-plated hull is fitted with controls on the inside and tracks on the outside, it'll become a Viking, an off-road warrior that can get troops in and out of any combat zone, even if it has to go through snow, sand, or water to get there. And it can keep its passengers protected, even under fire. In June 2007, a squadron of Vikings filled with British Marine commandos were returning to base in Helmand Province, Afghanistan, when they suddenly found themselves under heavy fire. They had driven into a massive Taliban ambush. The Marine commander retaliated with onboard machine guns and smoke grenades. He was able to lead his squadron to safety with minimal loss of life. He gives credit for their escape to the speed, firepower, and agility of the Viking. The Viking BVS-10 is an armored amphibious troop carrier that breaks down into 4 major parts: the wheels, the treads, the rear cabin, and the front cabin. The Viking's bulletproof skin is made of ballistic steel and ceramic plates. The armor for the doors, the hood, and the roof is cut to size using a high-pressure water jet cutter, a combination of water and sand that knifes through the metal with surgical precision. The Viking's 2 cabins hold a dozen soldiers, 4 right up front and 8 in the rear, which can also double as an ambulance or weapons bay for carrying mortars or tank missiles. When the Taliban opened fire on the Vikings with rocket-propelled grenades and heavy machine guns, the Vikings' armored exterior protected the men inside. Once cut and bent into shape, cabin pieces are assembled in preparation for welding. A robotic welder lifts and spins the 5-ton cabin into position. Automated torches fuse the bulletproof walls together at exactly the right temperature. Every weld is programmed for accuracy and speed, and every millimeter counts. If the vehicle isn't welded together exactly right, it won't be able to handle the punishment that the rough terrain delivers, and the seams will crack under pressure. It takes 5 full hours to weld the cabin body. The body is designed with flat surfaces to avoid radar detection. The radar echo bounces off the surface in just one direction, which makes the vehicle appear smaller than it actually is. Once the front and rear cabins are complete, they're sent to be painted with an anti-reflective and infrared dampening paint. Once the hull has been painted, it's kitted out with electronics, air conditioning, and navigation systems. The 285 horsepower diesel engine is powerful enough to drive the 1.5 tons of steel at speeds up to 65 kilometers per hour. In the ambush in Afghanistan, the Vikings were outnumbered and outgunned, but they were able to outrun the Taliban and keep them at bay, returning 50,000 rounds of fire from their front-mounted heavy machine guns. And hiding behind a smokescreen of white phosphorus grenades, the Vikings tore over the tough terrain at high speed. The hydraulically controlled articulating joint gives the Viking its ability to move both horizontally and vertically, and handle anything the road can throw at it without breaking up. The girder and wheel system is designed to distribute the Viking's weight evenly, so it can glide over snow or swampy terrain where other tanks would sink. The girders that are the foundation of the wheel system are ground and then robo-welded to exact specs. The hard rubber suspension is what enables the tank to take a pounding. First, a rubber bearing is fit into the suspension. Then, 6 small road wheels are attached to their axles and installed on both sides of the girder. With the Taliban on their tails, the Vikings raced through rocky riverbeds and sharp hills without stalling or getting trapped in the mud. But when the deadly chase finally took them to the edge of the Helmand River, the Vikings had only 2 options: face the fire or swim. Coming up on Battle Factory, the Viking has to resort to its secret weapon. When a squadron of Viking armed troop carriers were ambushed by the Taliban, they found themselves trapped on the shore of the Helmand River. With the enemy on one side and water on the other, the Viking turned to its secret weapon, its ability to swim. It plunged into the deep water. The Viking's unique design allows this 1.5-ton vehicle to glide through the water instead of sinking like a stone. By applying rubber sealant to all the doors, windows, and openings, the watertight vehicle floats due to displacement. Its rubber tracks spin under the water dog paddle style to propel the vehicle forward. The Vikings managed to cross the river and transport the men to safety. Despite being outnumbered 3-1, its armored shell and go-anywhere track system got the troops home with minimal casualties. If you ask the Marines on the ground, they'll tell you without hesitation, if not for the Viking, nobody would have made it home alive. The final step is to attach the rubber tread. The hard-molded rubber is tough enough to keep on moving, even if the Viking rolls over an anti-personnel landmine. To install the track, the Viking is lifted off the floor. Then the tread is rolled over to the vehicle. A tread wheel is attached, and the rubber track is stretched tight over the road wheels. Now the vehicle is complete and ready for testing. First, the water test. The Viking runs the test course like a true amphibian, plunging into 3 meters of water and gliding along at full operational capacity. This test ensures that the cabin is leak-proof and that the Viking can maneuver underwater. Next is the terrain test, ripping through the deep mud and scaling up a 31-degree grade without slipping. True to its name, the Viking is built for battle on land and in the water. No matter what, and no matter where the mission, the Viking can get you there and back in one piece. This time, on Battle Factory, a helmet that's easy to wear and tough enough to take a bullet. A pocket-sized icon that's been lighting up the fight since World War II. A mobile filling station that fuels the front lines. And a simulated explosive that trains the mind for war. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When these delicate snowflake shapes are pressed together, they'll form a piece of headgear that's comfortable enough to wear to war and tough enough to take a bullet. On October 3rd, 1993, a squad of U.S. Special Forces rappelled out of 2 Black Hawk helicopters onto the streets of Mogadishu, Somalia, in an attempt to seize 2 enemy lieutenants. The operation went south when the Somalis shot down the choppers and stranded the forces in an overnight standoff that inspired the movie Black Hawk Down. The Special Forces ops were willing to risk injury or worse rather than wear the uncomfortable Army-issue helmets that blocked their vision and messed with the communication system. So instead, they wore hockey helmets to the firefight. U.S. casualties were high. a plan was put into effect to design a helmet that soldiers could wear that would protect them in situations like the Mogadishu standoff. By the time troops shipped out to Iraq, the Special Ops helmet had been transformed into a ballistic helmet with mobility, visibility, and comfort. The Special Operations Delta helmet breaks down into two parts: the attachments and the body. The helmet is made from a synthetic plastic material called Aramid. Sheets of the material are rolled out onto a cutting table and stacked on top of one another. It's the layering that makes the helmet anti-ballistic or bulletproof. Fibers are so tightly woven that the projectile gets caught in the web and expends a lot of energy trying to push through. More layers means more protection. Patterns are laid over the Aramid sheets and cut with a bandsaw. The operator wears a chainmail glove to make sure he only slices through the material. The Aramid is cut and piled into snowflake-shaped stacks. The stacks are rolled over to the press. Individual sheets are laid onto a mold in an overlapping pattern. Steamed heat and 150 tons of pressure fuse the layers together to form the helmet shell. Paint won't stick to Aramid, so once the shell is complete, an additional paintable layer is pressed on to form the outer surface. The helmet is hand-trimmed to remove the excess material. Holes are drilled for chin straps and rails for mounting optical gear. Up until the mid-90s, helmets hadn't evolved that far from the steel doughboy helmets of World War I. In Mogadishu, special forces were more likely to wear cloth caps than to be weighed down with a helmet that offered little in the way of real ballistic protection. When they did wear helmets, they were likely to be $40 adjustable hockey helmets to protect them from banging their heads, not stopping a bullet. So a helmet had to be developed that offered the same comfort as a hockey helmet, with the ballistic protection and utility of combat gear. One helmet from each batch is tested by simulating a worst-case scenario: a bullet to the head. A helmet is positioned 5 meters from an automated 9mm rifle. The rifle is loaded and fired. A bullet travels at almost 440 meters a second, directly into the helmet. And while it does damage to the outer shell, it doesn't pierce it, which means in combat, it just saved a soldier's life. Once the batch has passed the ballistics test, the helmets are trimmed and a rubber edging is applied. Now the helmets are ready for painting. Once the paint is dry, the helmet gets a camouflage coating using a process called hydrographics. The 5-color print comes on a film, which is cut to size and placed on the water surface. A chemical spray both dissolves the film and activates a bonding agent. The helmet is dipped into the vat through the print, which floats on the surface like an oil slick. The pattern sticks to the helmet, then a top coat seals in the design. The inside of the helmet is fitted with an adjustable harness, neck pad, and shock absorber inserts. The outside of the helmet is kitted with rails to mount tactical equipment like lights, gas mask, communication equipment, and night vision. All the comforts of a $40 hockey helmet with the necessities of modern warfare. So wearing it shouldn't be an option. It's just using your head. Coming up on Battle Factory, it didn't just light fuses and heat rations. This wartime legend even stopped a bullet. And these portable containers carry enough fuel to power an army. These ribbons of solid brass will get pressed into service as an icon that's known by its look, its sound, and its name, the Zippo. When the U.S. entered World War II, Zippo started building their lighters exclusively for the U.S. military. On the front line and in the foxholes, GIs found comfort in a battlefield smoke. From World War II through Vietnam, Zippos have played their part in the war effort to light fuses, hammer nails, and heat rations in a helmet. There's even a story that a Zippo, sitting in a shirt pocket, saved a GI's life by stopping a Viet Cong bullet. The Zippo lighter breaks down into the insert, which houses the fuel tank, and the outer case. To make the outer case, 1-ton coils of pure brass are spooled out to a stamping machine, where 60 tons of pressure produce the lighter bottom. Then, a hinge and the two halves of the outer case are slid into welding braces on a moving table. Next, an electrode welds the hinges to the case. The flip-top case is what gives the Zippo its distinctive sound. The cases are loaded onto hanger frames and primed for their chrome plate finish. First with a nickel bath, and then with a cleaning solution. Zippo has a long tradition of specialty engraving, which makes the lighter highly collectible. But some of the most sought-after Zippos are those personalized by the servicemen themselves. Called trench art, soldiers would engrave their names and messages on their Zippos. For many, their inscriptions became their epitaphs. The insert is made from stainless steel and shaped in a die-cast machine. The inserts are transferred onto a conveyor belt. The flints, or spark wheels, are loaded into an assembly jig, followed by the cams, which will eventually act as a catch for the lighter lid. The cam is what keeps the Zippo lid shut. A wick is inserted and cut. Then, all the remaining elements of the insert are added. Finally, a flint screw is driven home to hold everything in place. The completed insert is press-fit into the outer case. The Zippo gets a once-over, a final buff, and it's good to go. For over 80 years, as a veteran of countless military theaters, over 500 million Zippos have been produced and have lit up the lives of 3 generations of servicemen and women. Coming up on Battle Factory. No matter where the fight takes you, these fuel containers can keep your motor running, and a simulated battleground prepares the soldier for the real thing. When it's cut and welded, this military-grade material will make one tough plastic bag. And it better be. It's going to carry 125,000 liters of diesel and jet fuel, enough to service tanks, jeeps, and planes, wherever the front line is drawn. In war, fuel becomes a target. How that fuel gets to the front line can make the difference between winning a battle and losing lives. In World War II, fuel was transported and stored in heavy metal barrels. When the barrels came under fire, they either exploded or all the fuel was lost. Now, there's a portable filling station that can gas up a tank in minutes and take a bullet without exploding. The mobile filling station breaks down into two parts: the fuel container and the pump. The military-strength pump will be housed in an aluminum cage to keep the machinery stable and protected. Once the cage is assembled, the pipes and hoses are fitted, the meter is attached, and the pump's engine is mounted into the frame. These military-strength pumps can fill a tank at up to an incredible 950 liters per minute. If this pump were used on an average car, it would likely take only 7 seconds to fill the tank. In the combat zone, fueling a tank has to happen fast, or they're sitting ducks. The fuel tank is not a conventional one, but a large foldable and reusable container. The bag is made from a top-secret formula of polyurethane and nylon. Each one is designed specifically for the type of fuel it's carrying and for where it will be deployed. And the shape is also not an accident. When a bomb goes off, it's the shock wave that can take out a vertical structure like a barrel instantly. But with these low-profile containers, the shock waves run into little resistance, so they roll right off the top of the container. In World War II, gasoline was stored in heavy metal barrels and pumped from large metal tanks. If the tank was pierced by a bullet, it had to be drained completely before it could be repaired with a welding torch. When these fuel containers come under fire, the hole can be plugged in seconds with a temporary screw plug, then permanently repaired with glue. To construct the fuel container, the sheets are joined together using radio frequency welding. Working like a microwave, it liquefies the top urethane coating from the inside out. The result is there's no longer a seam left. The pieces are bonded together at the molecular level. These seams will last for 10 years. There are two holes in the fuel container called flanges. One on top is used to pump fuel into the container, the other to pump it out. And the seal around those holes is critical. To make sure the fuel container is field ready, every seam, seal, and flange is tested. The bladder is overinflated with air, and a soapy liquid called leak tech is brushed on. If there's a leak, a bubble will form. An air leak here means a fuel leak in the combat zone. Thousands of dollars of fuel could be lost and put lives at risk. It passes the test and is ready for action. The container is then folded, loaded up, and prepped for travel. 6 of these mobile fueling stations can fit in an average shipping container. This is the equivalent of 8,700 metal barrels. In fact, Europe is still cleaning up the mess from World War II. Barrels are still being found today. Once it arrives on site, the folded container expands to 10.5 by 10.5 meters with a capacity of 125,000 liters of military-grade fuel. Each one holds enough diesel to gas up 107 Leopard 2 battle tanks. That's the equivalent of over 2,000 cars. Whatever the mission, these containers will fuel the fight. Coming up on Battle Factory, These special effect explosives mean gaining battlefield experience without losing your life. This aluminum bar is about to be transformed into a revolutionary training tool that could make the difference between life and death. Landmines and IEDs, or improvised explosive devices, are as lethal as they are terrifying. They've killed more than 3,000 troops and wounded 3,000 more since coalition forces landed in Iraq and Afghanistan in 2003. IEDs and landmines are often buried and triggered with a cell phone or remote control. Tough to spot and deadly. One wrong step could be your last. These surprise attacks cause panic and confusion. The first instinct is to freeze. But when you freeze, you become a target and a liability to your squad. In the past, it's been impossible to mentally prepare for these deadly threats without putting the soldier's life in danger. Now, a military simulation special effects company has created the ultimate training tool. When detonated, they unleash a sensory assault without causing injury. A soldier learns to handle the sounds and smoke of an IED blast while keeping his cool and carrying on with his mission. Explosion effect simulators break down into three parts: CO2 cartridges, the remote control, and the canisters that generate noise and smoke. Using precision craft and aluminum parts, assembly can begin. The first step is the burst disc, which seals the canister. This will house the special effects powder. It's locked into place with a robotic press. The components are pressure fit to complete the canister, and now work can begin on the remote detonation system. To replicate battlefield conditions, the explosion effect simulators have to be triggered from a distance. All the component parts of the remote detonator are soldered, tested, and fitted into a durable housing that can be stowed out of sight or buried underground. The detonator sends low-frequency pulses to the canister. It can receive a radio signal from up to almost a kilometer away, as long as there is a clear line of sight. The U.S. military has mocked up a number of Afghan villages to simulate the sights, sounds, and even the smells of a combat zone. Marines are subjected to immersive training scenarios, bombarded with the extreme mental and physical stresses of insurgent IEDs and street-level firefights. These high-stress simulations train the soldier to adjust fast and perform better in real-world situations. The trainer prepares for the field test by arming the explosive effect simulator. Each cylinder is filled with FX powder that will discharge a blast of smoke and a pressure cap that will produce an ear-splitting boom. CO2 cartridges are locked and loaded into the back of the canisters. On the training field, the explosion effect simulator is tethered to the receiver and hidden from sight. Anticipation and heightened response time can be the best weapons against an enemy when the rules of engagement don't apply. Learning to stay cool and maintain focus in this simulated attack psychologically prepares the soldier for the real thing. It could mean saving his own life or that of a buddy when he's in the chaos of battle. This time on Battle Factory, a combat suit for hiding in plain sight. A troop carrier with teeth that'll bite into any terrain. A pump truck that can shoot on the move. And a new take on a classic sidearm. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. To do his job and stay alive, a sniper needs to keep the target in range and stay out of sight. A sniper may position himself as far as 2 kilometers away from his target. And like a chameleon, he needs to blend into his background. And for that, he'll need a ghillie suit. The ghillie suit breaks down into the living layer, the burlap, and the smock. Ghillie suits are the ultimate camouflage, handcrafted by the sniper himself during training. It starts as a smock made from fine netting. The entire uniform is sprayed with an anti-reflective compound that reduces infrared signature to make it less detectable by night vision and thermal imaging scopes. The shoulders, arms, and chest area are softened so it looks less like a human form. The way to achieve this is with thousands of strands of material looped into the uniform's smock. Unraveled burlap looks natural and works best. The burlap is pulled apart by hand until there's enough thread to cover the suit. To match the foliage, some of the burlap is dyed. The multicolored strands are threaded into the netting to create uneven patterns. The burlap threads are tied to the mesh, covering the back, shoulders, arms, and chest. The softened silhouette will disappear into the background. Every sniper is an elite soldier, a sharpshooter in top physical and mental condition. During training, snipers spend over 100 hours of their own time hand-making their ghillie suit. It's part of their rite of passage. The same mesh burlap combination that covers the uniform is turned into a head-covering veil that hides the sniper's face and obscures the firearm. Ghillie, which means green man in Gaelic, was first invented by Scottish shepherds, hired by the landowners to protect their flocks from poachers. The Lovett Scouts, a Scottish Highland regiment formed by the British during the Boer War, were the first soldiers to use ghillie suits. And in 1916, became the British Army's first sniper unit. Once complete, the ghillie suit is distressed by dragging it through the dirt. Finally, the suit is sprayed with a fire retardant to make sure sparks from the rifle don't ignite the flammable burlap fibers. In the field, the sniper collects local vegetation, fastening bits of twigs, leaves, and grass to form a suit that's a perfect match for the surroundings. In every sniper force in the world, ghillie suits are as much a part of the sharpshooter's kit as his rifle. Coming up on Battle Factory, a tough transport vehicle with a customized weapon system, and a fire truck for when the blaze goes beyond the city limits. When these ballistic steel plates are cut and shaped and welded together, they'll make the body of an armored personnel carrier that's built to be fast and flexible. The CV-90 is the next best thing to a battle tank, but faster and more maneuverable. It can be fitted with or without a turret, with weapon options that include machine guns, cannons, and grenade launchers. The CV-90 is the Swiss Army knife of heavy artillery. It can be customized to suit the mission. In 2007, in Afghanistan, the CV-90 first saw action during Operation Harakati Yolo, a ground offensive to oust Taliban militants from northern Afghanistan. The CV-90, carrying a Norwegian battalion, took heavy insurgent fire. In a high-speed chase over hostile terrain, it outran the enemy, then returned fire with machine guns and cannon rounds, until the CV-90s were able to beat back the Taliban and get the troops safely home. The CV-90 Armadillo breaks down into the turret and the tank body. The CV-90's armor plating starts out as laser-cut sheets of bulletproof metal. The automated beam also carves out holes for sights, cables, and weapon stations. Then, the precision-cut sheets are bent into shape under 1,800 tons of pressure. And now, all the pieces have to be assembled. The first step is to temporarily weld the pieces together. The body is hoisted onto a robotic welder that automatically performs thousands of accurate welds. The same job would take a team of human welders weeks to accomplish. But after a full day on the automated welder, this job is complete. Flaws in the welds aren't usually visible to the naked eye. The only way to find them is with an X-ray machine. There are critical spots on the CV-90 that will take the brunt of the weight when it's deployed. When the 35,000 kilo CV-90 hits a bump in the road at 70 clicks an hour, even a hairline fracture could put the whole frame out of whack. At the measuring station, techs use lasers and handheld probes to make sure that every surface and angle is accurate. The probe can tell if it's off by more than 0.05 of a millimeter, and if it doesn't line up with the other components of the vehicle, it won't be able to accommodate the modular weapon system. This particular CV-90 will be armed with a dual grenade launcher. Construction begins with the turret mounts. The turret is cut, bent, and welded using the same construction techniques that built the CV-90 body. This same turret can be customized with multiple weapon configurations, from as small as a .50 caliber machine gun, all the way up to a full-sized battle tank cannon. Wiring and cables will connect the turret to computer controls. If everything functions perfectly, the turret will be secured to the CV-90 body. Before the CV-90 sees active duty, it has to pass the test track. Running at 60 kilometers per hour, speed bumps are designed to rattle the frame, and then it's sent into the field to push the vehicle to its limits. This one tackles the terrain without breaking a sweat. The CV-90's options may change with the mission, but the objective is always the same: make it back alive. Coming up on Battle Factory, the fire truck you need when you have to take your water with you, and a .45 semi-automatic that's a century in the making. When this aluminum tank is finished, it'll hold 3,700 liters. That's enough water for a small swimming pool, or to put out a good-sized blaze. And it'll be sitting on the back of a mobile fire truck. Because when you can't connect to a hydrant or pumping station, you've got to take your water with you. In times of war, firefighters can't rely on conventional water supplies. During the London Blitz, thousands of camouflage water tanks were hidden throughout the city, and pumps were installed under the bridge to siphon water out of the Thames. In peacetime, the mobile fire truck is often dispatched to handle wildfires. And in war, it's often sent to places with no access to water. The Grizzly Pumper fire rescue truck breaks down into the water tank and the pump house. The pump house is the heart and brains of the fire truck. Gauges and wires are housed in an aluminum cabinet, which sits in the middle of the truck body and controls the pressure of the water jets. The pump house is fitted with pressure gauges and the wiring system that controls the power and temperature of the water jets, so the water doesn't freeze even at 40 below. The pump house cabinet is made up of 77 kilo sheets of marine-grade aluminum, which are fed into a hydraulic guillotine shear with 78 kilopascals of pressure that slice through the 5mm sheets. Then, the aluminum is bent into shape using a press brake. The cabinet is attached, and the pump house is complete. On this fire engine, the pump house is connected to the vehicle's main drivetrain, which powers a pump working at 4,700 liters per minute, or 5 times the pressure of an average garden hose. This pump and roll capability means the truck can spray water on the move. During the Bosnian War, fire trucks equipped with onboard water tanks fought the flames during the siege of Sarajevo. The subframe is made from high-strength aluminum, tough enough to hold the 3,700-liter tank. The subframe is cut and fused using metal inert gas welding. It keeps out impurities and strengthens the bonds. Then, the side cabinets are cut, shaped, and welded. The aluminum surface is buffed with the sander to prime it for painting. The subframe is then added to the side cabinets, forming the enclosure that'll hold the water tank. It's got a 14,000 kilo maximum capacity, so it can easily support the tank, which weighs about 4,000 kilos when full. The fire engine starts its life as a stock cab and chassis. Once the truck bed is ready, the pump house is lowered onto the chassis. Instead of transferring the heavyweight rear cabinet and subframe to the truck bed, it's hoisted over the shop floor so the truck can get underneath it while it's lowered onto the frame. Then, the tank is dropped in. The pump house is connected and wired to the truck's computer. This controls the water flow and makes sure the pressure doesn't get dangerously high. A remote-controlled nozzle is mounted on the front bumper, which can pump out a constant 250 pounds of water pressure per square inch. That's about 500 times what comes out of your kitchen faucet. The seats installed in the truck's cab include built-in oxygen tanks, so when the firefighter mounts up, he can slip right into his air supply. For additional O2, extra tank holders are bolted to the cab exterior. The ladder is slid into a side compartment. Lights are installed. Now, this fire engine is ready to battle any blaze. No matter where the call, the Grizzly Pumper Rescue Fire Engine can bring the fight to the fire. Coming up on Battle Factory, the military's most enduring sidearm aims high. This block of steel will be transformed by innovation and artistry into the ultimate update of an American classic. An iconic sidearm and a formidable weapon. The 1911 semi-automatic handgun was invented over a century ago by second-generation gunsmith John Moses Browning, one of the fathers of modern firearms. The 1911 did tours of duty in both World Wars and Vietnam, and is still prized today by collectors and enthusiasts. The design has changed very little in the last 100 years. The 1911 breaks down into the slide and the frame. The frame of the Cabot 1911 is carved out of a high-purity block of steel with a water jet cutter. Water mixed with sand can slice through the thick steel with ease. What comes out of the water already resembles the 1911 signature profile. Once it's been cut, the body is machined on a CNC, or computer numerical controlled router. Water and lubricant flood the machining compartment to cool the metal and reduce friction, while the body details are tooled and holes are drilled to exacting specs of a 0.025 millimeter tolerance. The pistol body is again submerged in water, this time to conduct electricity. With both the metal and water electrically charged, intricate detailing is done using an EDM, or electric discharging machine. Stainless steel wire is charged with an electric current at 300 volts, then run through the magwell, carving the fine details onto the steel surface by literally burning off metal particles. The 1911 is now ready for engraving. The body is placed in a jig, a device that holds the gun steady for engraving. Using a cutter, the engraver etches out a serial number and the company details, so that every 1911 can be traced back to the day it was made. The slide of the gun is cut using the same water jet cutting method as the body. The spring-loaded slide of a handgun is pulled back to cock the hammer, then grabs the cartridge and pushes it into the chamber of the barrel on its way back. After it's cut, the slide is placed on a grinder and shaped to perfection so that it'll marry perfectly with the body. The measurement is so exact, it's the equivalent of splitting hairs 30 times over. Using a surface grinder and drawing on years of muscle memory, the final filing is done by an experienced hand, smoothing out the surface. What makes this gun special is that it's constructed to fit together perfectly without any adjustments or alterations. Called clone technology, The frame and slide are probed inside and out with a coordinate measurement machine to make sure they conform to exacting measurements. The measurement room has to be exactly 20 degrees Celsius. Plus or minus 1 degree can cause the steel to expand or contract. Finally, the gun is treated and assembled. Since its creation in 1911, the semi-automatic pistol has been an icon and the stuff of legend. But the most incredible 1911 story comes from World War II, when Lieutenant Owen J. Baggett's plane was shot out of the sky over India. He bailed out, only to become a floating target. A Japanese Zero fighter plane was headed straight for him, machine guns drawn. At the last moment, Baggett raised his holstered 1911 and fired 4 shots into the cockpit. The Zero went into a nosedive. One man took on the most notorious Japanese fighter in the sky with nothing but his 1911 sidearm, and he won. For over a century and through countless battles, the 1911 has been locked, loaded, and ready for action. This time on Battle Factory. Carried to safety on a bed of shock-absorbing springs. A medal that commemorates supreme sacrifice. Jumping out of a plane when the drop zone is a combat zone. And a lightweight fighting vehicle gears up with heavy firepower. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. Stitching these sheets of lightweight material together can create an air-resistant canopy that can drop a fighting force out of the sky and turn the tides of war. When Leonardo da Vinci first conceived of the parachute in 1483, he may not have realized the impact it would have on warfare. 5 centuries later, the Allies launched Operation Varsity. On a single day in March 1945, 16,000 British and American infantry were dropped onto the eastern banks of the Rhine, securing strategic towns and bridges and playing a pivotal role in the Allied victory. The RS-2000 military parachute breaks down to the chute pack, the harness, and the canopy. It takes 90 meters of tear-resistant material to create the parachute canopy. The idea of a parachute is simple. A canopy traps a large volume of air, creating enough resistance to dramatically reduce your terminal velocity. So you can jump out of a plane and land softly on the ground. But the design of a parachute is actually quite complex. The RS-2000 is made of 2 types of nylon, airtight and porous, which lets some of the air through. Hundreds of individual panels of both fabrics are laid out, measured, and machine cut on a diagonal. This prevents any rips or holes that might occur from spreading while in use. The panels are sewn together into 7-meter wedges. The combination of airtight and porous panels help to soften the tug of the canopy opening and stabilize it during descent. Nylon tape is used to ensure the seams are tight. A rip in the air could prove fatal. Then they are laid across a light table. Every seam is meticulously checked to make sure they overlap perfectly and will hold under pressure. The wedges are sewn together and the seams are checked again. It takes 30 of them to create the parachute canopy. A circular vent is left open at the top of the parachute. This vent prevents the canopy from opening too fast and too hard and jerking on the harness with a painful jolt. The suspension lines are what connect the canopy to the jumper's harness. Each parachute requires 30 lines, which are cut into 9-meter lengths and pinned into place. Then, they're sewn into the parachute's nylon seams. Once the parachute is complete, it's blown open with compressed air. Every seam and fitting is inspected before the canopy is folded up and put inside the chute pack for deployment. The harness is what suspends the jumper from the canopy. It's made from very strong nylon strapping that is measured and cut with a heat knife to prevent the ends from fraying. The strapping is secured together with a series of buckles and clips to make an adjustable harness that loops around the shoulders and legs. On an airborne mission, paratroopers typically jump from low altitudes to minimize exposure to enemy gunfire. For safety and simplicity, the chute opens automatically moments after the jumper leaves the plane. A 4.5-meter yellow static line runs from the cable on the plane to the jumper's chute pack. When he drops past 4.5 meters, the static line opens the pack and frees the canopy. Next time this chute sees daylight, it could be a kilometer above the ground, and every paratrooper who steps out of a plane is taking a leap of faith that his chute is going to let him down easy. Coming up on Battle Factory, a stretcher that suspends the victim in comfort and security, and a medal to honor those who gave everything in service of their country. These simple springs aren't just designed for a pleasant ride. The Yellow Jacket basket's unique shock-absorbing suspension will protect a victim who's already in trouble from further injury. In search and rescue, getting the victim swiftly and safely to medical attention is critical. But sometimes the stretcher, which consists of 2 poles and a piece of canvas, does more harm than good. Now, the Yellow Jacket is the paramedics' answer to an age-old problem. The stretcher breaks down into the shell, the springs of the insert, and the frame. The first step in building the frame is to measure out lightweight aluminum tubes. It takes 41 precision-cut pieces to construct the stretcher frame. Each piece is bent into shape on a digital pipe bender. Every angle is programmed into the press so that every piece fits together. Then, the 2 largest rods are hammered together to make up the outside edge. Next, it's placed on a jig, an adjustable device that locks all the pieces in place so they don't budge while being welded. Once everything is locked down, the frame is welded together. The yellow basket was inspired by a rescue gone wrong. A construction worker had fallen into a deep pit and broken his leg. Firefighter Ian Bassendale was among the first responders to haul the victim out. They eased him into a conventional stretcher and strapped him in with ropes. On the way up, the victim slipped, causing a simple fracture to become a painful compound fracture. Bassendale vowed to build a stretcher that would keep a patient secure and safe, no matter how steep the rescue. The shell is a lightweight innovation that keeps the patient secure at any angle. The super tough plastic can withstand extreme cold and heat and can take a beating being dragged over rocks and snow. Holes are cut into the pre-made shell so that it'll fit snugly onto the frame. The stretcher bed is cut from extremely durable nylon reinforced vinyl. The pieces are stitched together using tough nylon thread. The innovative belt system is designed so the victim can be transported securely at any angle. And each of the belts is tested to 5,000 pounds. So once you're buckled in, you're not going anywhere. Before the yellow basket, it took 45 minutes of lashing with rope to prep a victim for an aerial rescue. Now it takes just minutes to secure the passenger for an airlift. The spring system is what gives the stretcher its unique shock-absorbing capacity, and the difference between a safe ride and a potentially damaging one. 10 individual springs secure the bed to the aluminum frame. The springs are distributed around the frame to maximize shock absorption, doubling up at the head and hip area, where the patient is heaviest and most likely to be hurt. The stretcher can take the weight and take the hit. Finally, the stretcher is then lowered onto the shell and clipped into place. The Yellow Jacket stretcher has revolutionized the rescue process for over 5,000 first response agencies and military organizations around the world, ensuring that the trip to safety is a success. Coming up on Battle Factory, awarding the highest honor for the greatest loss. And the business end of the Stryker armored vehicle. These 1,000-ounce bars of pure silver bullion can be worth tens of thousands of dollars apiece. So one pallet alone can be worth over $1 million. But some of Canada's bravest have paid a much higher price. The Sacrifice Medal was created in 2008. And today it's been awarded to 780 Canadians wounded or killed in the service of their country. In Afghanistan in 2007, a deadly IED blast wounded a young soldier named Simon Mayou. As a result, his left leg had to be amputated. 2 years later, Simon was awarded the Sacrifice Medal and became the first Canadian amputee to be returned to active duty. He flew out the very same night as his medal ceremony. The medal is manufactured at the Royal Canadian Mint in Canada's capital city, Ottawa. Over $1 billion worth of precious metal is stockpiled here. So armed guards and closed-circuit cameras track every movement inside the mint. From the metal design to engraving the die, creating the Sacrifice Medal requires skill and care. The Sacrifice Medal breaks down into the ribbon, the suspension, and the medal. Using a design approved by the Queen in 2008, the front side of the 3.5-centimeter disc is engraved with the image of Queen Elizabeth II, the head of state and the armed forces. On the reverse is the statue Canada from the Vimy Ridge Memorial, the symbolic mother of a nation grieving for her fallen. The digital image is transferred onto a steel die and used to strike the sacrifice metal. The bars of fine silver that will make up the metal are lined up in a conveyor belt and carried into a machine that cuts them into thirds so they'll fit into the casting furnace. Then they're hand-fed into the furnace, which reaches 1250 degrees Celsius, in order to turn the precious metal to molten silver. The silver comes out in water-cooled slabs, about 13 centimeters wide and various thicknesses. Then, the shiny strip is wound into 450 kilogram coils, about 2.4 meters long. In the rolling room, the coil is unspooled and rocked back and forth to thin out the slab to a higher gauge. To keep the silver soft, it's reheated in another furnace at 500 degrees. It's put back on the roller, and finally the silver strip is thin enough for the basic shape of the metal to be punched out. A blank is then prepped for striking. It's blown clean and placed in the press. During the striking process, the die strikes the design onto both sides of the silver disc with several hundred tons of pressure. Once the metal is struck, it goes into a mill where the edges are shaved smooth. A hole is drilled in the bracket, and the suspension, which will hold the ribbon, is attached. Before being awarded, the medal is suspended on a multicolored ribbon. The red stripe is symbolic of spilt blood, the black symbolizes loss, and the white stripe represents hope and peace. For soldier Simon Mayeux, going back to the battlefield didn't just take courage. He had to prove he'd overcome his disability, marching 14 kilometers on his artificial limb, digging a foot-deep trench, and carrying a fellow officer for 100 meters. Soldiers like Mayeux, those who made it back, those who didn't, are emblematic of the bravery, the service, and the sacrifice that merit the sacrifice medal. Coming up on Battle Factory, 1 cannon, 4 kinds of ammo, and a round every 6 seconds. This tube of forged steel will be hammered into one of the most powerful and famous cannons in modern warfare. Today, the M68 105mm cannon sits on the turret of a Stryker armored vehicle, but it's a cannon with a long and storied history. During the Gulf War, the 105 was mounted on the turret of a Patton M60 battle tank. In February 1991, the 1st Marine Division spearheaded the liberation of Kuwait. It looked like the advance would be uncontested until the Iraqis attempted a daring counterattack. The Americans, in Patton M60 tanks armed with 105mm cannons, were forced to go head-to-head against hundreds of Saddam's tanks and armored vehicles. Over 20 years later, this cannon is still a force to be reckoned with. A battle tank is only as effective as its gun, and for the Stryker vehicle, that's the M68 105mm cannon. First, a block of gun steel is heated in a furnace for an hour at 2,000 degrees to soften the metal. Then, a jaw-like mechanism called a chuck grabs the tube and pushes it into the rotary forge. In the forge, 4 synchronized hammers strike the tube with 200 tons of force. As the hammers pound at its surface, the tube rotates. This process lengthens and shapes the red-hot metal as if it were clay. Coming out of the forge, the cannon has stretched in length from 3.3 meters to 6.8 meters. The cannon is lifted onto cooling racks to cool for 24 hours. Then the cannon is reheated in another oven with open flame for about an hour and then cooled with water. This process hardens the steel. After all this heating and cooling, the cannon develops bends. A shell launched from a warped cannon will veer off its target and might even misfire. To straighten the cannon, it's hoisted onto a vertical press. The tube revolves while a probe measures it, and the operator marks any warps. Next, 1,000 tons of pressure is applied to the areas that are warped, and the cannon is made perfectly straight. During the Gulf War liberation of Kuwait, Saddam's tank units launched a fierce attack against the U.S. troops. They responded with force. The Patton M60 was a superior tank, and the 105mm cannon meant the Americans could get shots off from 2 kilometers away, outgunning the Russian-supplied T-64s. Hours later, the Iraqi arsenal lay in ruins, while the Americans didn't suffer a single loss. This marked the end of Saddam's occupation of Kuwait and the beginning of its liberation. First, the cannon spends 6 hours rotating on a lathe. It machines off the rough exterior metal called bark, leaving behind a shiny, clean finish. Next, a machine drills through the length of it to make the inside opening of the barrel wider. Then, it is honed by rotating grinding stones inside the cavity to smooth it out and bring the barrel close to size. Synthetic oil reduces the extreme heat and friction. When it's finished, the diameter will be exactly 105 millimeters, the measurement that gives this cannon its name. Once the inside has been smoothed out, the cannon barrel is checked for cracks and imperfections. The interior is brought to spec, and the breech end of the cannon is threaded so it can be attached to the tank. Finally, the cannon is rifled. Helical grooves are carved onto the inside walls of the barrel, which causes the shell to spin when it fires. This stabilizes its trajectory and improves the aim. By the mid-1980s, the 105mm cannon ceased to be the largest tank cannon out there when the M1 Abrams was built. But the 105 is still a force to be reckoned with. These days, it does duty on the top of a Stryker, an armored fighting vehicle. And with the 105mm cannon riding up top, it now wields the power of a battle tank. This time on Battle Factory. The military menu that feeds the fight. The weapon that puts flexible firepower in the soldier's hands. And get the real feel of flying without ever leaving the ground. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. This packet contains enough food energy to keep a soldier fueled for the fight. The MRE, or Meal Ready to Eat, is a nutritious food ration distributed to servicemen and women in the field that can be heated on site in mere minutes. 100 years ago, dinner in the trenches of World War I wasn't as appetizing. Due to short supplies of staples and poor preservation, British troops subsisted on thin soups flavored with mystery meat, canned corned beef, and bread substitute made from dried turnips. Tins of sugary tea masked the flavor of water transported in gas tanks. Today, combat meals have been replaced by the MRE. The MRE breaks down into the flameless ration heater, the pouch of water, and the meal bag. The meals ready to eat must be prepared in a sterile environment to prevent bacterial contamination. One recipe is made at a time in an industrial kettle. First, the pre-cooked ingredients are brought to the kettle. Today on the menu, chicken with barbecue sauce, black beans, and potatoes. The preheated barbecue sauce, fortified with extra vitamins and minerals, is pumped into the kettle. Then the ingredients are poured into the sauce and mixed. Frozen chicken, dehydrated potatoes, and black beans. The MRE is health food and haute cuisine compared to the C rations of World War II. The C stands for combat, but it might as well have stood for canned. Canned meat, canned bread, and canned dessert. Affectionately known as C rats, they were only intended to feed a GI for a few days before being supplemented with real food. But toward the end of the war, C rations were all they got. By the late 1950s, the Army accumulated such a large stockpile, they were able to feed soldiers these temporary meals right through the Vietnam War. The meal bags are made from a combination of strong, flexible plastic and metal foil, making them highly durable and puncture resistant. The barbecue chicken meal is now pumped through a reservoir at the filling machine. The meal bags travel along a conveyor system where they're stamped with the ingredients, the plant number, and the date of production. Then, each bag is blown open with air jets, and the 228-gram meal is pumped into each bag. Each kettle can produce 1,400 meal bags every 20 minutes. Before being sealed, the bag is blasted with air to make sure no food is blocking the mouth of the bag. Then, the bag is heat sealed. An 8-hour shift can produce up to 100,000 meal bags. By the time the World War II C rations had arrived in Vietnam in the late 1960s, they were over 20 years old. And because the paper label often slipped off, every meal was a surprise. Today, MRE menus include Asian and Caribbean dishes, and there's even a vegetarian option. When the packages arrive at quality control, they are X-rayed for impurities. And every batch is sterilized and monitored. Samples are put into testing bags and sent through a sterilization chamber along with the rest of the batch. The monitors track the exact temperature, ensuring that the contents of the meal will be safe when reheated in the field. If a soldier gets sick to his stomach on the battlefield, he's at risk to himself and a liability to his squad. So food in the combat zone needs to be plentiful and safe. Every MRE contains 2 entrees and 2 sides, like high-energy bars and drink crystals, for a total of 1,300 calories. The packages also contain a pouch of water in 2 plastic bags called the flameless ration heaters. The bottom of the bag is a package containing magnesium mixed with metallic iron particles and table salt. Adding water causes a chemical reaction that heats it until it boils. The meal bag is inserted and left to heat, and the meal is ready to eat in 10 minutes. The final step is to seal the bags with cutlery and napkins. Then they can be packed and ready to ship to the field. War is no picnic, but if an army really does travel on its stomach, the MRE is the fuel that gets them to the front lines. Coming up on Battle Factory, a weapon with 150-meter range that doubles the fighting power. And climb aboard this craft, and you can take off without a runway or an airplane. Using the latest technology, these harmless bits of plastic will be melted and molded to create a snap-on weapon that drastically increases the firepower in a soldier's hands. The M203 grenade launcher is a single-shot launcher designed to attach under a rifle barrel. In World War I, the original grenade launchers were the infantrymen themselves, who both lit and lobbed the mini-bombs from the trenches. They could throw the grenade 15 meters fairly accurately, but would have to duck for cover to avoid the shrapnel from the explosion. The Leach Trench Catapult was the first attempt at a solution, sending the grenades as far as 200 meters, but the aim was iffy. Today's version has both range and precision. The M203 grenade launcher breaks down into the barrel, the hand grip, and the receiver. The receiver of the grenade launcher is what contains the firing mechanisms, houses the barrel, and connects the launcher to the rifle. It starts off as a block of aluminum that's precision cut on a CNC, or computer-controlled machine. Once cut, the probe calculates the exact measurements to make sure that every dimension is to spec. It was originally designed to fit on the M16 rifle, but is currently compatible with many rifle models. Once the receiver is passed inspection, it's engraved with the serial number and registration code for security and quality control. Next, the receiver is anodized. The aluminum is dropped in an acid bath and charged with electricity, which alters the property of the metal surface, making it harder and rust-resistant. Once the receiver is treated, its moving parts can be added. First, the barrel latch locks the barrel and receiver together. Then the barrel stop goes in to prevent the barrel from sliding off the receiver during loading and cocking. Next comes the firing mechanism. The firing pin and cocking lever are inserted into the receiver and held in place with a locator pin. Then the safety, the trigger, and the trigger guard are installed, and the receiver is complete. World War II saw the advent of a rifle grenade that worked like a mortar and could travel 140 meters. A rod attached to the bottom of the grenade loaded into a standard rifle barrel. This crude launcher damaged the rifle and compromised its utility. Today, the modern grenade launcher doesn't damage the barrel since it's slung underneath, turning the gun into a double-duty weapon. With the hand grenade, once you remove the firing pin, you had 4 seconds to throw and run. The modern grenade launcher arms and detonates its payload differently. When the grenade is launched, the centrifugal force of the spinning missile arms the fuse. When the grenade hits the target, the firing pin is pushed back into the percussion cap, sparking an ignition, so that the grenade explodes on contact. The hand grip is a molded plastic sleeve that slides over the barrel for easy loading and protects the operator from burns. The grip is made by injection molding. Plastic granules are suctioned into the hopper, piped into the molding machine, and injected into the mold. The combination of heat and friction liquefy the plastic. Once the plastic is set, the mold opens and expels the hand grip. By the 1950s, the U.S. military had developed the M79, a purpose-built grenade launcher that looked like a shotgun with a huge barrel. These were used in Vietnam, but once the soldier was out of grenades, all he had left to defend himself was his small sidearm. So the U.S. military developed the M203 to fit on the M16 rifle. The launcher barrel is constructed of the same specially treated aluminum and is attached to the receiver. When the launcher is assembled, it gets a full function check to ensure the barrel latch and stop are doing their jobs. Finally, the receiver assembly is attached to the rifle barrel, and the M203 grenade launcher is ready to deploy. With the M203, the soldier can switch between weapons in seconds and engage targets that can't be reached by direct fire, converting a rifle from a weapon into an arsenal. Coming up on Battle Factory, the only airplane you can crash and reboot. It takes 12 months and millions of parts to create this structure that stands 9 meters high. But once inside it, you'll believe you're 9 kilometers in the air. Inside the cockpit of the CAE flight simulator, every nerve ending tells you you're flying, from the feel of the controls to the view out the window and the thrust of the G-force. In the military, by the time a pilot climbs into the cockpit of a real airplane, he's already had many hours of operational flying time without ever leaving the ground. It wasn't always this way. Prior to the advent of the flight simulator, learning to be a fighter pilot was actually more dangerous than flying combat missions. In World War I, 2 cadets were killed during training for every flyer killed in battle. Every simulator costs millions of dollars to make, but it's worth every penny. The CAE flight simulator breaks down into the motion control, the platform, the outer shell, and the flight controls. The flight control unit makes up the bottom part of the cockpit and houses the gears that control the flying movements the flight simulator makes, like thrust, pitching, and banking. The flight control unit and its many gears are milled from aluminum. The pieces are all modular and fit together like a complicated puzzle. The gears will eventually be connected to the hand levers on the control panel, the side stick, and overhead panel. They have resistance built into them to simulate the authentic feel of pilot experiences when driving the gears and controlling the aircraft. And every simulator is custom built to replicate a specific model of airplane, from civilian passenger jets to military fighter planes. The first simulator was developed by Edwin Link in the 1920s. He was an amateur flyer with a first-hand knowledge of engineering, electronics, and pneumatics from his family's pipe organ factory. He offered his Link trainer to the U.S. government in 1929, but they dismissed the concept entirely. The avionics panel contains the buttons, displays, and instrument panels that control the engines and navigation systems. Because every model of aircraft looks and flies differently, every simulator's avionics panel is a customized copy of the airplane it's meant to replicate. 3D printers generate buttons, knobs, and handles that ensure that the simulator's interface will look, feel, and function exactly like the model of plane that the trainee pilot will fly in the real world. Over 30 kilometers of cable are cut, identified, and thread into the panel. It takes hundreds of hours to do the intricate wiring. One error would cause the aviation panel to short circuit. Next, the brains of the cockpit, the circuit boards, are assembled. A programmed robotic machine grabs the tiny circuits and drops them in the slots on the circuit boards. Then, they're passed through an oven, and the circuits are fused onto the panel. There are hundreds of printed circuit boards in every simulator, performing thousands of operations per second. Today, flight simulators are a first option for training commercial and military aviators, but they got their start on the heels of a tough and tragic lesson. In 1934, Franklin D. Roosevelt recruited the U.S. Air Force to deliver airmail across America. Flying an aircraft that had been used in World War I, the pilots were given a civilian mission very different from their wartime experience. Pilots had to contend with stormy weather and unfamiliar airstrips. In the first disastrous month of the program alone, there were 66 crashes. The nation responded to this tragedy with an outcry. Roosevelt realized something had to be done. Coming up on Battle Factory, President Roosevelt turns to an unlikely source for help. In 1934, in the first few months of delivering the mail by air, the newly commissioned U.S. Air Force pilots were crashing all over the country. In desperation, Roosevelt and the Air Force reached out to the same person that had been rejected years before, Edwin Link. 6 Link trainers were ordered immediately. By the time World War II broke, there were 10,000 flight simulators in service. The cockpit module sits on top of the flight control unit and gives the interior of the simulator the look and feel of the inside of an aircraft. Built-in speakers broadcast everything from the roar of takeoff to the thunk of landing gear being deployed. Once the module is completely outfitted, it's raised onto the carriage and secured. The rest of the interior components are installed. The panels and doors of the platform are made from heavy-duty aluminum to handle the stress of the 10,000-kilogram simulator bouncing around for the next 20 years. The sheets of metal are cut and sent to a punch press that cuts the aluminum into various shapes and then bent. Then the components are assembled, painted airplane white, and baked to a hard finish. Once finished, the platform is attached to the flight control unit and the cockpit module. The simulator is capable of its unique movement because of the design of the bearings, which act like joints. They work together to choreograph an aircraft's 3 planes of motion: pitch, front to back motion, yaw, sliding on the vertical axis, and roll, tipping from side to side. Each of the bearing houses are made from aluminum and injected with grease to keep them lubricated. Each bearing will hold a leg known as a jack at either end, which allows the flight simulator to rock and roll. The visual bowl of the simulator, which is made out of fiberglass and aluminum, stands in for the cockpit window. The ever-changing visuals are projected onto a curved mylar screen, giving the pilot in training 180 degrees of virtual landscape. In the late 1950s, simulators would use film projection of scale model terrains, and then in the 60s, advanced to TV screens outside the cockpit. By the early 70s, computers were generating crude digital skyscapes. Today, the difference between a simulated and real cockpit is virtually indistinguishable, and the sophisticated flight programs can throw any dangerous scenario at the trainee. Extreme weather, equipment failure, emergency landings, and combat scenarios. 80 years after the first mail delivery disaster, pilots are required to do hours of simulator training. So by the time they climb into the real cockpit, they won't be winging it. Because once you've flown a simulator, you're ready to take off in the real thing. This time on Battle Factory. A watch for wartime that lights up in the night. A rescue tool that can chomp its way through anything. And a battle tank gets a makeover that makes it better than new. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. While they look like simple glass tubes, they'll soon radiate enough light to tell the time in total darkness. They call it the watch that won the war. June 6, 1944, D-Day. The Allied assault on German-held Normandy was the biggest coordinated land, air, and sea invasion of all time. Over 150,000 troops had to move in perfect sync. And to succeed, every division on land, sea, and air had to synchronize their watches to 6:30 a.m. sharp. In Vietnam, night maneuvers became standard military strategy. Soldiers needed to tell time in pitch black, creating the need for the luminescent watch face. Today, the Tracer H3 watch has all the technology to keep up with the times. The Tracer watch breaks down into the face, the Tracer ring, and the capillaries. The capillaries are the watch's light source, and they begin as a 1 centimeter glass tube. They're heated and stretched until they're 0.5 millimeters in diameter. These tubes, or capillaries, are cut to 60 centimeter lengths. This military watch doesn't just glow in the dark. The tritium hands and indicators are charged by a chemical reaction that will glow day and night, 24/7, for at least 10 years. And it starts with tiny glass tubes. Next, colored phosphorus powder is poured into the tubes and then checked under black light for even distribution. Different mixes of powder generate different colors. Green is the most popular because the human eye perceives it as brightest. The capillaries now shine under black light, but in order to make them glow in the true darkness, the powder is mixed with a minute amount of radioactive gas called tritium. It's worth $30,000 a gram. First, the tubes are attached to a device that will distribute the tritium. The glass tubes are flash frozen in order to better trap the gas. Then, tritium gas is pumped into the frozen capillaries and then heated to mix evenly with the phosphorus powder. A chemical reaction between the tritium and the phosphorus is what gives the tubes their luminescence. Then, the ends are pinched and sealed shut. The radioactive tritium is now encapsulated in the glass, making it completely risk-free for the wearer. Next, the tubes are laser cut into small pieces that will fit easily onto the watch face. The tiny light-filled capsules are checked under a microscope for size, shape, and glow factor. A robotic arm then lines up the pieces perfectly onto pallets in preparation for assembly onto the watch face. Assembling the watch face starts by adding capillaries to what is called a tracer ring, a ring which displays every hour. A robotic arm drops a glowing capillary into the hour indicators. Next, a capillary is added to each of the watch's hands. Then, the watch face and the tracer ring are pressed together. The watch hands are then carefully attached, and the outer case is mounted on top of the face and tracer ring. Finally, the back plate is pressed on and squeezed shut. The completed watch is then labeled with laser engraving. The Tracer H3 isn't just a pretty face. It's got to be deadly accurate under the most rigorous conditions. So the watch is dipped in a solution of salt water that's the same concentration as human sweat. It gets punched in the face, dropped on the ground, blasted with extreme temperatures, and shaken up to make sure nothing comes loose. If it's rugged enough to survive the test, a band is strapped on, the watch is tagged, and the tracer is good to go. On the battlefield where every second counts, keeping time means staying alive. Coming up on Battle Factory, a first response tool that cuts out a path to safety. And a complete overhaul puts this battle tank back in the battle. Each one of these handcrafted precision-cut pieces will come together to create a first response tool capable of chewing through metal like a can opener. At the scene of an accident, a natural disaster, or in the combat zone, the jaws of life can cut through just about anything to gain access to a victim and pluck them from the jaws of death. Prior to the 1970s, rescue efforts were performed using crowbars, winches, and circular saws, which had the potential to send sparks flying into gas-filled wrecks. In addition, they all needed power from an external source. Today, the Jaws of Life spreaders and cutters are handheld and battery-operated and weigh under 23 kilos. The Jaws of Life cutter breaks down into the cutter, the pump body, and the cylinder. The cylinder starts as a length of solid aluminum, which is cut down to 45 centimeters. Then, the ends are ground to smooth out any sharp edges. The cylinder is placed inside an automated lathe. First, the end is turned and threaded. Then, the center is bored out. Next, the cylinder is secured in a computer-controlled cutting machine. While the metal is showered with jets of anti-friction liquid, sections for the center are milled out and the area where the cutter will attach is carved. The same process is repeated to produce the piston, which moves the heavy cutting blades or jaw. The pistons move in and out of the cylinder under hydraulic pressure to open and close the jaws. The piston is fitted with O-rings, then lubricated so it can slide into the cylinder without damaging the interior. On September 12, 2001, one day after the tragic attacks on the Trade Center in New York, 2 Marines sifted through the rubble at Ground Zero, and they heard cries for help. Using the jaws of life, rescuers were able to cut through concrete and metal girders and reach 2 Port Authority cops who were buried 30 feet under the concourse and pull them out alive. Next come the cutter blades, which act more like a nutcracker than a pair of scissors. In fact, the blades only make a small initial cut into the metal. Then the sheer force of the jaws actually fracture it like a stone. And they have a force that can crack through almost 4 centimeters of solid steel. Special heat-treated metal is used to ensure that the blades are tough enough to chew through concrete, steel, and brick. Next, a steel pivot pin secures the blades together, and a lock nut fastens them tight. Finally, flexible rubber guards called blade boots keep the sharp end of the tool away from the operator's hands so it can be used safely. The jaws of life are powered by a hydraulic pump, which is housed in the pump body. The pump body is fitted with an electric motor and a bladder filled with 1 liter of hydraulic oil. The incredible force of the cutters is achieved by pumping fluid under very high pressure into the cylinder. The fluid forces the piston up and opens the arms of the cutter. The operator can then toggle the switch the other way and cause the piston to retract, which closes the arms. The engine runs on a battery, which is powerful enough to make 40 cuts without replacement. The pump engine is screwed onto the end of the cylinder, which is then covered in a protective plastic case. Before they can be put into the field, the jaws of life undergo a series of tests. The first test measures the jaw's power by biting down hard on a pressure-sensitive gauge. If the jaws don't bite down hard enough, it doesn't leave the plant. Next, the hydraulic pump is tested for leaks. Once it's field ready, final touches are added and it's packed up and shipped out. The jaws of life's next assignment could be a car crash or rock slide, a smoke-filled Humvee, or a building toppled by enemy mortar fire. And it may have to cut through twisted metal or concrete walls. But the goal is always the same: get rescuers in and victims out alive. Coming up on Battle Factory, an overhaul puts this tank back in fighting shape. This tank is in for an overhaul, and it's going to take 1,600 man-hours, several months, and $1 million to get this battle tank back into fighting form. And it's worth every penny. On February 24th, 1991, at the height of the Gulf War, U.S. tanks and armored vehicles raced east from Saudi Arabia into Iraq in a daring flank maneuver, later nicknamed the Hail Mary. The armored vehicle that would lead the attack was the coalition force's heavy hitter, the M1 Abrams tank. The M1 Abrams tank is the U.S. military's top gun. Since it rolled onto the battlefields in 1991, it's been the toughest, fastest, and smartest fighting machine on the ground. After 5 to 10 years of service, these $8 million tanks get battle-weary. and it's cheaper to refurbish them than to purchase new ones. And kitted with current technology and innovative add-ons, these rebuilt M1s will be better than new. The M1 Abrams breaks down into the turret, the engine, and the hull. Weighing in at 62 tons, each tank is shipped in by rail and lifted off the track by a 40-meter-high crane. It's towed into the factory, and deconstruction can begin. First, the turret is uncorked from the hull and hoisted onto a transport dolly. It will take 4 months alone to dismantle the tank down to its 12,000 parts. Some parts will be tossed, some will be refurbished, and some will be replaced with better quality components. The complete overhaul will take 10 months. Next, the 2,300-kilogram tank tracks are removed, rolled, and carried off on a forklift. The wheels and suspension are stripped off, leaving the empty 37-ton hull. The hull is armored with a composite of ceramic and spent plutonium that can withstand the enemy's best shot in a tank battle. The Abrams can dish it out, and it can take it. The hull is lifted onto a large dolly, which transports it to a massive bay called a spinner hangar. Then the crane moves the hull into a vertical position. Next, it's placed safely behind 10-meter-high, 7-ton doors. Inside, millions of tiny steel pellets are blasted at the rotating tank hull, stripping away old paint and corrosion. In 90 minutes, the hull surface has been scraped back to its original metal. Next, certain spots on the hull are cut so the tank can be retrofitted with upgraded computer and weapon systems. Next, it's primed and painted with a durable military-grade paint, giving the tank another layer against the elements. The M1 Abrams' unique engine and transmission are called the Power Pack. It combines a 1,500 horsepower turbojet engine with a 6-speed hydrokinetic transmission. The tank can accelerate from 0 to 30 kilometers per hour in 7 seconds and travel at speeds of up to 70 kilometers per hour. The Abrams engine is versatile and will run on just about anything that will burn, including gasoline, jet fuel, and even perfume. The engine and transmission take 4 weeks to overhaul. When they return from battle, they're coated with dirt and riddled with rust. Sand is the nemesis of the Power Pack, and in current theaters of operation, sand is everywhere. In February 1991, in the thick of Desert Storm, a squadron of American M1 Abrams battle tanks rolled towards Iraq. The mission? Cut off the Iraqi threat to Kuwait and take down the Republican Guard divisions near the Iraq-Kuwait border. The Americans were hoping for a surprise attack, but they were spotted. A squadron of hundreds of Iraqi tanks manned by the elite Republican Guards geared up for what was to be a classic standoff. Coming up on Battle Factory, the M1 Abrams turns a blinding storm into a Hail Mary maneuver. In the early hours of February 26, 1991, American forces were headed for a face-off against the tank units of the Iraq Elite Republican Guard. The outcome of the skirmish would play a deciding role in the success of the Iraq War. The Americans' offensive line was led by 36 M1 Abrams. They had hoped to have the advantage of surprise, but a slow advance gave away their position. Then, a sandstorm swept through the desert, cutting off their air support and reducing visibility to zero. They were on their own, outgunned, and heading into battle. After 8 months of the rebuild, the M1 Abrams is ready to be put back together. Its hull has been stripped, it's been repainted, outfitted with armor, and the engines have been rebuilt. All of the tank's parts have been either retooled or replaced. It's time to reassemble the 68-ton giant. Then, the tracks are laid out. A dragline pulls the tracks over, and they're wound onto the sprockets and road wheels. Then, connectors are hammered in to hold the tracks in place. The turret fits back onto the hull like a 21-ton cap into the refurbished ring. It's a tough, delicate operation, lowering the heavyweight turret and a 6-meter cannon until it's perfectly aligned. In a blinding sandstorm, U.S. forces found themselves up against an unseen enemy. But the M1 Abrams could turn this desert storm to their advantage. Equipped with revolutionary GPS systems, they were able to navigate through zero visibility and pull a Hail Mary flank move to sweep around the Iraqis, who they'd ID'd with thermal imaging. And when the sand cleared, the Americans were right on top of the Republican Guard. They didn't stand a chance. Before returning to the battlefield, the M1 Abrams has to survive the proving ground. A series of rigorous tests designed to push the tank to its limits and assess every aspect of the rebuild. Failure here could mean casualties in the combat zone. The tank tears through its paces, testing speed, target lock, and turret rotation, mobility, and sharp angle climbs. The M1 Abrams is battle ready. After 10 months, the refurbished tank is better than before, maybe even better than when it came off the line the first time around. The U.S. Army plans to keep on refurbishing this model until 2040. By then, there will be M1 Abrams that have served 50 years of active duty, that are veterans of the last great tank battle of the 20th century. This time on Battle Factory, a non-lethal bullet that's targeted for training. A ceremonial sword that still leads the charge. And a supersonic dogfighter that does it all. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. This chunk of carbon steel will be honed and hammered into a military icon that's as old as war itself. Used as the primary weapon in battle for over 5,000 years, over time, the sword became lighter, sharper, and even more deadly. However, by World War I, fighting style had changed. Hand-to-hand combat was replaced by trench warfare and the machine gun. The sword saw little action. But 100 years later, it still performs a ceremonial role, symbolizing rank, courage, and honor. Today, every British soldier who achieves the rank of officer has the privilege of wearing a sword. This workshop south of London is one of the last where cavalry swords are handcrafted individually, using techniques that are centuries old. Designed in 1912, the cavalry sword breaks down into the handle, the guard, and the blade. The blade begins as a billet of raw carbon steel. Carbon has been used in making swords for over 1,000 years. It's ground into its basic shape and dipped into oil. Then a groove called a fuller is ground into the flat side of the blade. Also known as a blood groove, the fuller is designed to make the sword lighter and easier to pull out of the target. The blade is baked in an oven to harden the steel. Then it's cooled or quenched in oil. The hardening process sometimes causes warping, so in order to straighten it, it is first heated with a blowtorch. Using a press that looks like it hasn't changed much in centuries, the warps are pounded out of the blade. Then the bladesmith finishes the straightening with a hammer and an experienced eye. The blade is then tested to make sure it's flexible enough to bend without breaking. And it's struck against a rounded metal surface to make sure it can take the impact without cracking. Finally, the blade is polished to a high mirror finish. While the cavalry sword was obsolete by World War II, one eccentric soldier, British Lieutenant Colonel John Churchill, maintained that any officer going into battle without his sword was improperly dressed, and he became known for charging into battle wielding his sword. His nickname became Mad Jack. Etching swords is an art that's been practiced without much change since the Middle Ages. Thick red paint fills the patterns in a steel mold. Then it's transferred onto paper. This cavalry sword is marked with a decorative pattern, and the royal cipher, the ER2, stands for Queen Elizabeth II. The paper is gently rubbed onto the blade and peeled off, leaving behind the painted pattern. Then the blade is dipped into an acid bath for 20 minutes. The paint is acid resistant, so when the sword is removed and rinsed, the paint is scraped off, leaving the ornate pattern etched in the blade. This technique has been used for hundreds of years. The cavalry sword has an ornate guard that was originally designed to protect the swordsman's hand. Its basic shape is traced onto a metal sheet and cut. Then, the pattern is silk screened on with paint and dipped in acid. Once the pattern has been etched on, the guard is pounded into shape on a press, then hammered home by hand. The traditional wood handle is wrapped tightly in actual stingray skin, a unique leather that's been used for centuries. Once it's glued and dried, the skin is painted. Finally, silver wire is wound into the handle's grooves to give it a good, solid grip. Mad Jack, the last soldier to carry a sword in World War II, was ordered in September of 1943 to capture a strategic German-held post in Salerno, Italy. Hopelessly outmanned, Churchill crept through the base, swooping in on unsuspecting soldiers and drawing his sword. Mad Jack captured 42 Nazi soldiers, took the German post, and earned himself a Distinguished Service Order. Once all the components have been created, the blade is locked onto a table vise and the sword is assembled. The guard and grip are slipped onto the blade and bolted on tight. Then the pommel, an ornate cap, completes the sword. The sword hasn't been relied upon in combat since the exploits of Mad Jack Churchill, but it will forever remain a part of military dress and military history. Coming up on Battle Factory. This bullet won't kill you, but it will make you stronger. And a scrappy little dogfighter that's been Top Gun for 40 years. These aluminum rods and plastic pellets will be molded and machined into simulated ammo that fires like the real thing. When it comes to training options, this is number one with a bullet. Urban warfare is a harsh reality of today's military theater. Adrenaline-fueled operations that take the soldier directly into the enemy's house, facing attack from behind doors and around corners. By late in World War II, Allied troops needed to train for urban warfare in a real-world setting. So, residents of the English village of Imber were asked to leave their homes so U.S. troops could train for D-Day on their streets and in their houses. In close-quarter combat, panic, fear, and blind aggression are inevitable. And the closer the soldier can get to the real thing, the more effective the training will be, right down to taking a bullet. Simulated ammunition is a cross between a bullet and a paintball. It fires like real ammo, it hurts, it leaves a mark, and it lets soldiers know with dead certainty if they've hit their target or become one. The man marker simulated ammunition breaks down into the components, the cruciform dome, and the slide. Made from rods of aluminum, the slide will house the component parts of the simulated slug. The rods are dropped onto a conveyor belt and turned on an automated multi-spindle lathe, which spits out 50 finished slides per minute. Every slide passes through a high-speed sensor, which analyzes it for quality and measurement. If it detects the tiniest speck of debris, or if the size is off by even 0.001%, the entire batch is rejected. Then the slides are laser engraved with the production date. The plastic cruciform dome is the outer casing of the bullet. First, plastic pellets are put into a dryer. Then, they're molded to form the little plastic domes that make up the tip of the simulated ammo. This process outputs 500,000 domes every 24 hours. Once the components are completed, they're conveyed to a robotic assembly line. Each of the bullet's 10 parts is dropped into individual hoppers and then fed into the machine. The slide is inserted with the projectile charge, a firing pin ball, and the rear power load. Then, an inertia applicator ball is installed along with the marking compound that leaves its telltale spot on the target. Finally, the plastic cruciform dome is capped on top. They may be simulated, but these bullets are fired from real guns, so that soldiers can train on the same weapons they'll be carrying into combat. After installing a conversion kit into the rifle's action, the magazine, loaded with simulated bullets, is ready for testing on live targets. The training ground is laid out for fishing, short form for fighting in someone's house. A firefight with simulated ammo gets the soldier used to being shot at, The projectiles break upon impact and leave a mark. And there's no mistaking the feedback. A red dot on your chest means you've been hit. In 2013, the U.S. Army built a 300-acre city to use as a facility for urban warfare and house-to-house confrontations. Simulated ammunition plays a critical role in these scenarios, and the way a soldier reacts to a simulated firefight could make the difference between walking out of that house and getting carried out. Coming up on Battle Factory. Whatever the mission, this lightweight skyfighter earns its wings. Brainpower and firepower transform 8,000 kilograms of computer-controlled machinery into a legendary dogfighter with the best fight and flight record in the sky. The F-16, known as the Fighting Falcon, is equally effective in air-to-air combat and air-to-ground attack. And at Mach 2, if you hear the F-16 coming, it's already too late. During the Vietnam War, the United States sustained dramatic losses. The F-4 Phantoms often struggled to take down the supposedly weaker Soviet MiG-21s at close range. So a maverick group of engineers known as the Fighter Mafia was determined to design a lightweight maneuverable jet that could handle both air-to-air and air-to-ground operations. And in 1974, they pulled it off. 40 years later, the modern version of the fighter jet is still almost identical in shape and size. The secret to its agility and speed is a sleek, compact fuselage. The F-16 breaks down into the aft, the center and wings, and the forward. The forward fuselage is the nerve center of the airplane and takes over 9 months to build. It houses the cockpit, gun trough, fuel tank, and the piloting and navigation systems that were a true innovation when the F-16 first took to the air. The forward fuselage starts as an aluminum shell. In the electrical harnessing station, over 70 kilometers of wire are strung through the fuselage, connecting the cockpit controls to navigational and weapon systems. Each wire is hung before install to allow it to stretch. A wire that shrinks or recoils mid-flight could be catastrophic. The F-16 is a fly-by-wire aircraft, which means that the pilot's commands are relayed electronically instead of employing the hydraulics. This decreases the number of moving parts, making the plane lighter and safer. When it was first introduced in 1974, pilots needed to get used to the feel of what they dubbed the electric jet. Once the wiring is complete, the forward is transferred across the factory to a test bay where every electronic and computer component will be analyzed to make sure the fly-by-wire system is functioning perfectly. Every control panel component is tested, from radar display to the targeting and navigational systems. They test the heads-up display, which projects navigational data and weapon status right onto the canopy glass. A real-world computer interface that shows the pilot where he is and where to target his missiles. Then the bubble canopy is attached and tested. It's made of high-strength polycarbonate that gives the pilot a 360-degree view. Finally, the forward is hoisted over to the flatbed and put aside for the mating process, where it will be joined to the center and aft sections of the plane. Since the 70s, the F-16 has always been known as the Fighting Falcon, but its sleek, compact forward fuselage earned the plane a new nickname, the Viper. Because of daring missions like in May of 2011 involving aggressive diving, quick strafing fire, and deadly use of missiles, the bird became a snake. The center fuselage houses the landing gear, the in-flight refueling system, and the wings. The center starts as a barrel shape. Panels are screwed onto the frame to keep the structure together. Next, bulkheads that act like ribbing are built around the barrel. These will allow room to house the fueling system, the electrical wiring, and make space to attach the landing gear. A metal skin is attached to the outside of the structure. The aluminum skin is made to be subjected to the extreme temperatures and stress caused by flying at supersonic speeds and at altitudes up to 15 kilometers in the air. Once complete, it's set aside to wait for mating. The aft fuselage houses the exhaust port and the small fins and wings that help to steer and stabilize the plane. Once all the pieces of the fuselage are completed, they're transported to another hangar to be assembled. On a mission in Afghanistan, high above the desert floor, F-16 pilot Major John Caldwell spotted a small unit of U.S. and coalition special forces being ambushed by almost 100 Afghan insurgents. He decided to take them on. He armed his F-16's Gatling gun and braced himself for the fight of his life. Coming up on Battle Factory, the F-16's exploits earned the Fighting Falcon its nickname. While on a routine patrol, F-16 pilot Major John Caldwell caught an ambush in progress. A small Special Forces team had been attacked by an insurgent cell and were fighting for their lives. Caldwell swooped in and laid down strafing fire with his aircraft's 20mm gun to create distance between the insurgents and Special Forces squad. Then he pulled his aircraft up, came back around, and dropped a satellite-guided bomb on the attackers, neutralizing the ambush. Caldwell was awarded a Distinguished Flying Cross. The Fighting Falcon lives up to its nickname, the Viper. In the mating station, the completed pieces of the aircraft's fuselage are dropped into a fixture to be joined together. It's a precise and painstaking operation. Next, the tricycle landing gear and vertical stabilizers are installed. The fuselage is hoisted onto a ceiling-mounted crane, and the horizontal stabilizers and wings are installed. The radome, or nose of the aircraft, houses the F-16's state-of-the-art radar system, which detects standard environmental elements like wind and airspeed. The F-16 is powered by a turbofan engine, which can accelerate the aircraft to more than twice the speed of sound, or over 2,200 kilometers per hour. The F-16's smart, modular design means that the engine can be removed, serviced, and replaced easily in any airfield in the world. Once it's assembled, the F-16 is transported to an environmentally controlled paint hangar. The temperature is kept at exactly 23.9 degrees Celsius, and the air is filtered of debris, which can cause millions of dollars worth of engine damage. The classified paint formula contains rubber, which masks the aircraft's heat signature and reduces radar detection. Once it's painted, the F-16 is ready to hit the runway and take to the air. Since its initial production in the 1970s, over 4,500 F-16s have been produced for 28 different nations. For 40 years, the Skyscraper has proven to be the best fighter in and beyond its weight class, defending its reputation as the dogfighter that does it all. The F-16 is never coming down. This time on Battle Factory. After almost a century of service, this big gun still calls the shots. The perfect makeup for a disappearing act. And over land or underwater, this is the only way to go. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. These dull gray steel rods and plain metal plates will be machined into a deadly arms weapon that's been the U.S. military's go-to big gun for almost 100 years. The M2 machine gun is a 50 caliber belt-fed air-cooled heavy machine gun that's considered one of the most effective and destructive weapons of all time. The first gun capable of firing continuous rounds was the Gatling gun, invented in 1862 by Richard Gatling and employed by the Union Army during the Civil War. It was a rapid-fire machine gun, but still needed a person to hand-crank the barrels. By World War I, machine guns made use of the bullet's recoil force to reload the next bullet and became the first truly automatic weapon. The M2 was first designed by legendary gunmaker John Browning at the end of World War I and has since been in production longer than any other machine gun. Today, the M2 machine gun is even used as a heavy weapon mounted on board armored vehicles and battleships, and is still the top choice for anti-aircraft and infantry support. The M2 breaks down into the receiver and the barrel. The barrel of the M2 starts as a 1 meter long blank made of cryo-treated weapons-grade steel, which means it's been cooled to minus 185 degrees Celsius to harden and strengthen the metal. It is tough enough to handle 600 rounds of ammo per minute and is tested to well over 15,000 rounds. First, the barrel blanks are heated in an oven to keep the barrel from warping during machining. Then, the blanks are mounted on a lathe where the center of the barrel is bored out. A drill bit creates the initial hole in the center of the barrel, which is then widened and honed. Once complete, the barrel is ready to be rifled. Rifling is a process that etches grooves into the interior walls that cause the bullet to spin as it flies, which improves aim and accuracy. While the barrel rotates counterclockwise, a drill bit turns clockwise to rifle the inside, creating helical grooves on the interior walls. When the bullet leaves the barrel, it'll be traveling at 840 meters per second. Next, a lathe scrapes off additional debris from the outside of the barrel. Once the barrel is complete, the work starts on the receiver. The M2's receiver is the part of the gun that makes it an automatic weapon. It houses all the operating parts, and it's built to receive the ammunition belt, and it can fire 10 rounds every second. The M2 is a recoil-operated machine gun, which means that the energy provided by the recoil powers the loading of the next round. Used cartridges are rejected from the bottom of the gun. Side plates make up the outer walls of the M2's receiver. The plates are magnetically held in place and then cut on a computer-controlled cutting machine. The feed bracket, which feeds the belt and ammo into the receiver, is installed on the right side plate. Next, an orbital riveter rounds out the metal to secure the rivets. It is so powerful that it can manipulate the tough metal as easily as if it were clay. Heat is used to expand the rivets for a tight fit. Then the excess material is ground away. Next, the top plate is installed, followed by the bottom plate and the breech assembly. The M2 can be set up to fire a single shot for pinpoint accuracy up to 2,000 meters away, and then switch easily back over to sustained automatic firing mode, firing for as long as the trigger is held. The M2 hasn't changed much in the last century since Browning first designed it. In January 1945, in the north of France, the M2 lived up to its full potential. An American infantry company led by Lieutenant Audie Murphy was attacked by a German tank unit. Murphy ordered his men to scatter into nearby woods. He got behind his M2 machine gun to take on an entire German tank platoon. After an hour, the brave soldier and his machine gun held off 6 advancing heavy tanks. He foiled the counterattack and secured the American key position. After the war, Audie Murphy's art reflected his life. He starred in countless adventure films, many of them World War II movies. Murphy went from a machine gun-wielding hero to an icon of the silver screen. Next, the assembled receiver is sandblasted to scrape off a thin layer of steel. This is in preparation for exposing the receiver to chemical baths. First, the receiver is dipped in a chemical bath that makes it rust-resistant. Then, it's neutralized in a water bath, and finally coated with chrome sealant. Then, the receiver is baked in an oven for 4 hours at 80 degrees Celsius to dry out every crack and crevice and prevent the internal rusting that could weaken the gun. Now, the M2 is ready for assembly. The barrel support is attached with holes that help vent the heat created by semi-automatic fire. Then the final attachments are added, and it's ready for testing. Once the M2 is built, it's taken out to the firing range. 100 rounds are cycled through it so that every moving part is tested for functionality and accuracy. Once the M2 is ready, it's sent out for active duty. Coming up on Battle Factory, camouflage cover-up that really covers up. And the driving, climbing, go-anywhere amphibian. They're just globs of color now, but when applied to a soldier's face, they could paint him right out of the picture and maybe save his life. Camouflage makeup is designed to make a soldier disappear. This military-grade compound is a long way from department store concealer. It's sweat-proof, infrared-resistant, and stays on in a drenching downpour. In the early 20th century, combat became more covert. And by World War II, soldiers were applying camouflage makeup to hide in plain sight. In the jungles of Vietnam, Navy SEALs always wore makeup during their operations and became known to the Vietnamese as the men with green faces. Camo makeup breaks down into the case and 3 different shades of paint. The base of the camo paint is solidified vegetable oil. It's basically the same stuff you'd use to make French fries. It's sectioned out into blocks in preparation for heating and set aside. Then, colored powder is measured out. The pigments are shades of green and brown that can be adjusted for jungle operations and nighttime raids. The secret anti-infrared ingredient makes the wearer less visible to thermal imaging scopes. Exposed skin reflects light and attracts attention, so camouflage is often applied in 2 colors in an irregular pattern. Shiny areas are painted with a dark color, and shadow areas are colored with a light color. Next, a polysorbate is weighed out. This emulsifier allows the ingredients to bind together. It also makes the paint creamy, so it's easy to apply and remove. A preservative ensures that the paint won't spoil in the field. Finally, a thickener is added to make the paint sweat-proof. Then the ingredients are blended together. Each color has its own mixing vat. Like a chef's recipe, the ingredients are added in a prescribed order, starting with the vegetable oil bricks. First, the oil bricks are heated to 90 degrees Celsius to melt them into a thick fluid. Then, the powdered pigment is poured in, followed by the rest of the ingredients. The concoction is mixed for 2 hours until the blend is smooth and creamy. When the paint is complete, it will not only be long-lasting and sweat-proof, but perfectly safe to wear. In the days before the D-Day invasion of Normandy, a legendary paratrooper unit were the first soldiers known to use camo paint, not as camouflage, but to strike fear into the hearts of the enemy. The demolition squad shaved their heads down to mohawks, covered their faces in war paint, and earned the nickname the Filthy 13 when they refused to wash their uniforms until victory was theirs. Their daring exploits were mythologized in the 60s war movie, The Dirty Dozen. Once the paint is ready, mirrored cases are placed on a rotating carousel. Each of the 3 colors is injected into a separate compartment. The case is then fed down the line onto a vibrating conveyor. The vibrations settle the paint into its compartments. Each compact is then tapped to settle the paint further, check for flaws, and sent to packaging. Every compact is labeled with the ingredients and expiry date. Then they're boxed for shipping to soldiers in the field. In the combat zone, soldiers will often work in pairs to apply the camo paint. Soldiers, especially special ops and snipers, wear camouflage uniforms to blend into the background. Camo paint completes their covert coverage, so they can get to their target before they become one. Coming up on Battle Factory, wheels turn to paddles when this road warrior hits the surf. Once these 8 wheels are locked on, this all-terrain vehicle won't just roll, it'll swim. The Argo Amphibious ATV is a nimble personnel carrier that can handle rocky roads or muddy swamps, plunging into rushing rivers and paddling through deep water. Light enough to drop out of a helicopter, the Argo is the go-to ATV for special ops units, border patrollers, and first responders. Amphibious vehicles were first developed for the military in the years leading up to World War II. They combined elements of cars and boats to access places that neither alone could get to. By 1944, when the Allied forces stormed the beaches of Normandy, larger amphibious vehicles were a critical part of the arsenal. Today, the lightweight and versatile Argo is the evolution of these first-generation amphibians. The Argo breaks down into the engine, the transmission, the wheels, and the body. Part of what makes the Argo amphibious is its lightweight, waterproof body. Unlike a car, the ATV's outer body is made of 2 pieces of polyethylene joined together in a watertight seal. In a large thermal forming machine, a sheet of specially designed plastic is heated to 177 degrees Celsius for about 20 minutes. The machine inflates the softened poly, forming a kind of plastic balloon. As it rises, the metal die rises up against the plastic surface, and the air is sucked back into the machine. This negative pressure molds the plastic against the die to form the shape of the ATV's upper section. Once it's cooled and hardened, a tech drops a jig onto the molded plastic. The jig lines up with the body shape and guides where to punch out holes for wiring and throttle controls. Then, the engine hood and waterproof battery compartment are removed from the mold and trimmed of excess plastic. The bottom half of the body looks and performs like the hull of a boat. Holes are routed for axles and water drainage. The next step is to make the chassis. The lightweight frame of the ATV is made of high tensile strength steel alloy, cut and welded into shape, which will support the body, the engine, and suspension system. Then, the chassis is set aside until assembly. The key to Argo's Go Anywhere capability is its state-of-the-art Admiral transmission system. Almost 40 different gears will go into this revolutionary transmission, fully engineered and manufactured on-site. The gears are constructed on a computer-controlled machine that cuts each gear out of high-strength steel alloy. Jets of coolant keep temperature and friction down. When a gear is finished, an automated rotary arm extracts it from the machine and picks up another piece of steel for milling. The Admiral 8-wheel drive transmission means every wheel is getting power from the engine simultaneously and rolling independently. This gives the Argo incredible mobility. It can pull 360 turns with ease and ride over just about any surface. After the ATV played a critical role on the beaches of Normandy, it would help to make inroads in the liberation of German-occupied Europe. In 1945, as the Nazis were retreating through Holland, they flooded the landscape to try and bog their Allied pursuers in the mud. In their attempt to escape capture, they also put the occupied Dutch beyond help. If the Allied forces couldn't traverse the terrain to reach the Dutch people in time, it wasn't just delaying their liberation. It also meant death by starvation. Coming up on Battle Factory, the Allies send help by getting on board a buffalo. In the final days of World War II, the German army was on the run in what was once occupied Holland. They tried to create distance between them and their Allied pursuers by flooding the landscape, which stranded the starving Dutch citizens. But the amphibious vehicle of the day, the Buffalo, was able to get troops and supplies through the water and over the mud. The amphibious vehicle foiled the Germans' plans and became instrumental in the liberation of Holland. Once construction of the Argo amphibious vehicle is complete, components are assembled. First, the transmission is dropped into the chassis and secured. Then, the chassis is lowered into the bottom section of the molded body. The transmission and drive chains are cabled and connected. The frame is secured, and the engine, mechanics, and electronics are installed. A self-adhesive waterproof gasket is applied to the edges of the bottom section of the body. The upper body is lowered onto the bottom, and the sections are clamped together to make sure the watertight adhesive bonds. The two halves of the ATV are riveted together to keep it watertight. With the body complete, the wheel assemblies are bolted in. Gaskets surround the axles to keep the water out. The tires have a raised tread, enabling the Argo to swim in deep water. When the wheels spin in the water, it acts like a paddle so that the Argo is propelled forward. Rough edges are trimmed of excess plastic. Dust is blown clear, and the ATV gets a function check. The battery is sparked, and the engine gets a good rev to make sure the Argo is alive and kicking. Now that it's field ready, the Argo is put to the test. The Argo tears through the course, swimming through deep water and skimming over rough terrain. Steep curves and sharp turns are child's play for this agile ATV. But on military assignments around the world, the Argo is all business. This time on Battle Factory. The scope that's right on target from 2.5 kilometers away. An airborne supply system that delivers the goods from 9 kilometers up. These boots are made for marching. And one of the most imitated handguns ever made. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. This aluminum block will soon hold a piece of ground glass that has the power to extend a sharpshooter's eye, so he can see, stalk, and connect with a target that's kilometers away. The rifle scope is small, lightweight, and has a revolutionary fog-proof lens, so the glass will not fog up no matter what the weather. The sophisticated rifle scope began in the 17th century as a set of crosshairs, actually made from human hair or spider webbing, and mounted on the tip of a rifle barrel. But today, with advances in rifle and scope technology, elite snipers have made record shots at seemingly impossible distances, up to 2.5 kilometers from their target. The loopholed rifle scope breaks down into the lenses, the erector system, and the main body. The body starts as 3.7 meters of aluminum tubing. The blanks are placed in a computer-controlled cutting machine where they rotate on a spindle. First, the eyepiece end is cut. Then, the objective end, the side that faces the target, is machined. Rifle scopes have 3 main sections that magnify an image: the objective lens, the internal erector lenses, and the ocular lens. As the light passes through the series of lenses, the image starts upside down and is then flipped back before being magnified. Next, the erector system of the scope is machined. The pivot tube, which will hold the internal lenses, and the cam tube, which slides over top and controls the movement of the lenses back and forth. Next, the eye shell and lens holder is machined and washed. Finally, mounting rings are cut. These will fasten the scope to the rifle barrel. The rings are then stamped with a logo and set aside for coating. Next, it's sandblasted to prep the body to be anodized, a chemical treatment that coats and protects the aluminum. During the Vietnam War, the legendary American sharpshooter, Carlos Whitefeather Hathcock, became one of the Viet Cong's most feared snipers. An equally lethal Vietnamese sniper known as the Cobra was enlisted to take him out. Meanwhile, Hathcock was tracking the Cobra. While stalking his adversary, Hathcock caught a momentary glint in the undergrowth and fired at the reflection. He sent a bullet directly through his enemy's scope, killing the Cobra. Later, Hathcock realized the only way he could have made the shot was if he and the Cobra had been looking directly through their scopes at each other at the exact same moment. Lucky for him, Hathcock fired first. After being anodized, the scope is now a matte black. All the anodized parts are placed in a carrier basket and ferried through a series of tanks containing detergents and cleansers that prep them for a 100% sterile environment. In a clean room, the eyepiece is assembled. Then, the rings are glued together and the ocular lens is dropped onto the eyepiece. Then, the erector system is assembled and the main tube is put together. Once the scope is fully assembled, it is calibrated to make sure the optics and mechanics line up perfectly. When a sniper is taking aim, he may not be putting his target in the crosshairs, but adjusting his scope to compensate for distance, temperature, and wind velocity. The scopes are then inserted onto blocks, and a tiny piston shoots inert gas into the main tube. This will prevent fogging in the field no matter what the temperature or humidity. Then the scopes are fitted onto a carousel and put through the dunk test. If any bubbles are visible, that means there's a leak. Finally, the adjuster tubes are added for wind variation, elevation, and focus. The scope sits securely on the rifle barrel. The shooter squints through it, putting his target in the crosshairs, making minuscule adjustments. This refined melding of precision optics and crafted mechanics all come down to one moment and one shot. Coming up on Battle Factory, the airborne care package that can find its own way to the drop zone, and military footwear from boot camp to the battlefield. When they're packed up, these containers will be giant care packages, bringing airborne aid that can make the difference between help and being helplessly stranded. And not only can they fly, they can get there on their own. Precision Aerial Delivery System, or PADS, are guided by GPS. Computer coordinates program the airdrop, and built-in motors using pulley systems steer the package for up to 15 kilometers, transporting loads of supplies and landing within 100 meters of the drop zone. While the military had been dropping bombs out of the sky since World War I, it was only in the Second World War that they began using their planes to airdrop food, medicine, or weapons to soldiers operating deep behind enemy lines. But these airdrops were hit and miss. Packages often landed kilometers away from their targets. Today, NATO considers precision airdrops among its top priorities for humanitarian aid and defense against terrorism. The Sherpa model breaks down into the parachute, the payload, and the guidance unit. The black box, called the Aerial Guidance Unit, consists of two small metal compartments that fit together. The first step is to assemble the upper half, or the muscle of the guidance unit, which contains the basic driving mechanisms and pulley system. The pulley system will tug on the parafoil's lines to steer the Sherpa to its drop zone. The lower half is the brains of the unit. It houses the GPS software that can track where it is and where it's headed. A stack of computer cards receives location information from the GPS receiver. It computes a flight path to the target point and instructs the parachute when to open. The onboard receiver means that the unit can also be controlled using a remote control. A battery is installed and the two halves are assembled. Now, the aerial guidance unit is ready for rigorous testing. If the drop is from 9 kilometers over the desert, the temperature starts at a freezing 50 below, then soars to plus 40 as it lands on the burning sand. So the pad's computer and mechanics are tested at extreme temperatures. The parafoil lines are connected to the AGU, and under simulated flight conditions, the steering mechanism is stressed to its limits. When it's passed the test, it's ready to be connected to the parachute. The parafoil is what makes the Sherpa fly. It's made from double layers of super strong parachute material called ripstop nylon. Once it's sewn together, every centimeter of the material is checked. Even the tiniest nick could shear it and bring a huge payload crashing down. When the space between the two layers of chute material fills with air, the parafoil becomes a rigid rectangle, like the aerodynamic wing of an airplane. A Sherpa can have up to 100 suspension lines made of very strong nylon, which is built to hold 10 times the weight of their designated payload. Once the lines have been methodically organized and laid out, the chute is packed into a bag. 2004 was the first time a GPS-guided PADS was used. A U.S. headquarters in western Iraq that was home to a hospital and Marine garrison was at risk of heavy insurgent attack. The only way to get the much-needed supplies was from the air. Deployed from high above enemy detection, the newly developed PADS floated downward and steered itself to the correct coordinates. The food and medical supplies landed safely in the camp. The final step is to integrate the guidance unit and the parafoil. The PADS has the brawn to deliver 4,500 kilo care packages to their destination and the brains to get there on its own. Coming up on Battle Factory, the boots that form a soldier's footsteps, and the world's most popular pistol. When these strips of leather are cut and cobbled together, they'll march a Marine through a life of service. The Army boot is a symbol of military life that takes the soldier from the parade ground to the battlefield, but they aren't all created equal. The Danner rugged all-terrain boot is built to keep the U.S. Marine warm, dry, and protected, whether he's trudging through a desert or slogging through swamp. But it's been a long haul getting here. The trench boot took its first steps during World War I in the cold, wet mud of Europe's Western Front. Made from rough-cut leather with hobnail soles for additional traction, the boots were coated with wax dubbin to waterproof them against the persistent damp and the threat of trench foot, a disease that caused a soldier's feet to literally rot in their boots. But the coating wasn't enough, and 75,000 troops succumbed to trench foot. As military theaters changed, design of the military boot had to evolve along with it. The Danner all-terrain boot breaks down into the liner, the sole, and the exterior. The first step is to check the leather for quality and strength. Then the hides go to the leather cutting station. Steel dies cut out the patterns that will form the outside of the boots. The leather is then stamped with the official insignia of the United States Marine Corps. An automated sewing machine double stitches the boot's leather quarter panel with extremely strong nylon thread. Then the rest of the pattern is hand sewn to complete the side panel, which will keep the ankle dry and protected. 12 eyelets are punched out for laces, and then the side panel of the boot is sewn together. Once the excess leather is trimmed, the exterior of the boot is complete. Using dies that look a little like Christmas stockings, the boot liner is cut out of waterproof, breathable Gore-Tex. The pleated halves are stitched together using a serging stitch that can easily accommodate the curved shape of the liner. The booties are then inflated with air and dunked into a water tank to check for holes. Bubbles indicate a leak, which means they are either repaired or thrown away. These Gore-Tex liners ensure that the boots can tramp through ankle-deep water without getting the soldier's feet wet, making the boots 100% waterproof. The boot is ready to be put together. First, hooks are added for speed laces, just like on ice skates. The lining is stretched into shape on a plastic foot mold. A felt insole board is coated with glue and pressed onto the bottom of the lining. The top layer of the boot is glued on, and the leather is stretched right over the toe. The boots and rubber sole are heated to over 90 degrees Celsius to activate the adhesive. A tack clamps the boot and sole together to complete the watertight seal. First, they test the sole's bond to the boot bottom. It takes almost 115 kilos of force before the sole gives way. The laces and eyelets are jerked around over 15,000 times and still refuse to stretch or tear. Then the boots are dunked in water and flexed 100,000 times to simulate a tour in swampy terrain. Life is tough enough for a Marine without worrying about what's underfoot. The right pair of boots isn't just part of the uniform. They're as critical to a soldier's survival as their weapon. Coming up on Battle Factory, a straight shooter that aims for accuracy. These bits of steel and spring and coated plastic will pack into a pistol that's one of the most popular sidearms ever produced. Designed in the Czech Republic, the CZ75 9mm pistol was first designed in 1975 behind the Iron Curtain. Its firepower and accuracy became legendary and has since been imitated by manufacturers around the world. Today, the CZ75 is the default sidearm for a long list of police and military forces. The pistol breaks down into 4 parts: the frame, the recoil spring, the barrel, and the slide. Every time the pistol is fired, recoil slams the slide back and pops out the spent shell. Then a spring bounces the slide forward, chambering a new bullet as it returns to firing position. The slide starts out as a piece of raw steel. A robotic arm grabs it and puts it into a computer-controlled cutting machine. The machine then carves out the basic shape. Automatically selecting from a series of cutting tools and drills, the machine further refines the slide, rounding the edges and cutting out an ejector hole to jettison the spent cartridges. Every member of the U.S. Special Forces, like the legendary Delta Force, is armed with a pistol. When a Black Hawk helicopter was shot down in Mogadishu, Somalia, 2 Special Forces snipers insisted on being airdropped into the fray in order to defend the wounded crew under siege by a mob of Somalian insurgents. Armed with only their sniper rifles and pistols, they established a perimeter to protect the wounded crew. The first soldier was killed, and the second stepped directly into the line of fire, holding them off with just his pistol until the very end. For the first time since the Vietnam War, both brave soldiers were posthumously awarded the Medal of Honor. The barrels of the CZ-75 arrive coated in rust. They're actually left outside during the changing seasons to be weather cured, which toughens the metal, a CZ family recipe. The barrel is made from a special alloyed steel, heat treated for hardness. Holes are bored through the center, 4 barrels at a time. Then, the rusty outer bark is scraped off. The barrels are placed in a cold hammer forge. 4 hammers pound on the barrel at 1,000 hits per minute with 10 tons of pressure to stretch and toughen the steel. During this hammering process, a spiral-shaped tool forms corkscrew grooves on the inside walls, called rifling. When the bullet is fired, the rifling causes it to spin, which makes it fly straight and aim true. Then, the rifling is inspected, and the interior of the barrel is cleaned. The frame is made from a super-strength polymer reinforced with fiberglass. The spring absorbs the energy of the recoil and protects the frame from the impact of the slide. Every time the pistol is fired, the recoil sends the slide back into firing position, chambering a new round as it goes. Finally, the slide and barrel are joined with the frame. The gun is complete and ready for testing. Every CZ pistol is strong enough to be dropped from 4 meters with a round in the chamber onto a concrete surface. It will hold together, and the coated polymer frame won't crack under impact. Finally, the gun is loaded up and lit up at the firing range. Since its inception in 1975, there have been literally thousands of imitators of the CZ handgun. But whether it's on the firing range or the combat zone, when you need to give it your best shot, you want to reach for the real thing. This time on Battle Factory. A remote-controlled eye in the sky. A hard-shell case that's an ER you can drop from a plane. How to keep yourself safe from the storm and hidden from prying eyes. And a monster truck that can really take a bullet. Battle Factory steps beyond the front lines into top-secret factories where combat gear is built for battle. When this construction of cogs, cables, and computer software hits the air, it'll become a flying eye in the sky and a high-tech bird of prey. UAV stands for Unmanned Aerial Vehicle, but these remote-controlled flyers, used for long-range reconnaissance and armed combat, are better known as drones. They come small enough to fit into a backpack or scale right up to a full-size fighter jet. It can outfly manned aircraft, staying aloft for over 24 hours at a time, often controlled via satellite link from a world away. The ING Robotic Aviation Responder is a surveillance drone that can reach speeds of 70 kilometers per hour. Weighing in at 45 kilograms, the $80,000 Helidrone is stable in extreme weather conditions and 60-kilometer winds. The Helidrone is currently deployed to East Africa, where the military use it to monitor border incursions. The Helidrone breaks down into the motor, the drives, and the frame. The mini-copter is made on a frame of carbon fiber, which is 10 times tougher than steel. The rest of the body is composed of strong, lightweight fiberglass, which won't disrupt the radio frequency signals that control the drone. The main gear drives the aircraft's main rotor and tail. All teeth on the gears are manufactured on a diagonal instead of straight up and down. This minimizes noise and vibration throughout the frame, which maximizes stability and stealth. Just like a full-sized helicopter, the drone is based on angled elements that provide lift and prevent the aircraft from spinning out of control. There are two drive systems, one in the main body of the frame and one in the tail. This two-way drive helps to stabilize the drone so it doesn't spin and helps with the yaw, or left and right turns. The drives are made of CNC machined aluminum. First, the tail drive is assembled. Next, the main drive is constructed. The main drive is responsible for the lift of the drone. Its curved holders steady the aircraft and minimize spin. Surveillance drones were first used extensively during the Vietnam War. Dubbed Firebees, they were equipped with conventional cameras and ran reconnaissance missions. Not much change for UAVs for 20 years, until drones were able to see details from half a kilometer up and transmit those images in real time. And the sound of a drone often meant an attack was going to follow. So, in February 1991, after a U.S. battleship had devastated the Iraqi defenses of Failaka Island near Kuwait City, the Navy sent an unarmed drone at low altitude over the island. When locals heard the drone's signature sound, they figured the low-flying aircraft was about to direct another precision strike. The troops started surrendering to the drone's tiny camera. It was the first time in history that people surrendered to a robot. Assembly begins with the landing gear. The lower landing portion is made of lightweight aluminum. The raised legs allow for 8 inches of clearance for mounting cameras and large sensors. The copter is wired and the onboard computer and power source are installed. The 500-watt battery-powered motor will reach speeds of 70 clicks and run for about 40 minutes without a recharge. Finally, the propeller blades are inserted into the main and tail drives. The responder is made to carry a DSLR camera, which takes super high-resolution stills and video from as high as 275 meters up. Top priority for the drone's test flight is to make sure the UAV is vibration-free. Even the slightest rattle makes for a bumpy ride, a drained battery, and blurry images. Drones are on the rise. Whether it's deployed for high-altitude surveillance or targeted air assault, the drone is a powerful and controversial combination of human skill and robotic technology, and a long-range look at the future of warfare. Coming up on Battle Factory. A shock-proof, leak-proof carrier you can drop out of the sky. And a DIY solution to surviving in the woods. These granules of lightweight plastic will be melted and molded into a hard shell, waterproof case that can be an emergency ward in a box. Until the early 1960s, military equipment and supplies were packaged and transported in wooden shipping crates. They were heavy and had to be pried open with crowbars, and once unloaded, they were trashed. These days, the shipping case is made from composite plastic. Lighter and more rugged than wood, the case can be clean enough to carry medical supplies and tough enough to drop out of a plane. They seal tight to keep out water, weather, and sand, while maintaining a constant atmosphere and sterile environment inside. The ECS case breaks down into the hardware and the body. Grains of sand-colored polyethylene are weighed out, then shoveled into a mold. Then a lid is put on, and it's secured to a robotic arm. First, the mold is rotated so the polyethylene grains inside are distributed evenly. Next, the arm moves into a large oven that heats the poly to 300 degrees Celsius for 20 minutes. Once heated, the granules of poly melt together to form a solid plastic that conforms to the shape of the mold. Then, it's shifted to a cooling bay, where an industrial fan dries it to a hard finish. Still hot to the touch, the cases are pulled from the mold. During molding, solid foam is placed inside the shell. As it cools, the case shrinks approximately 6 millimeters, and the foam inserts help maintain its shape. A blanket prevents it from cooling too quickly. Once it's cooled down, the foam inserts are punched out. After a further half an hour, the excess plastic edging, called the return cap, is shaved off. A blowtorch smooths out the edges, and a plastic soldering iron seals any spots where the shaving created holes. The surface is buffed, and an angle blade X-Acto knife trims off the remaining plastic shards. Finally, a flattening agent is sprayed to remove the unwanted reflective gloss left by the blowtorch. During the Korean War, mobile Army surgical hospitals, or MASH units, were set up as close to the front lines as possible, while still trying to keep the doctors out of harm's way. The result is that many people died on stretchers and in jeeps on the way to get help. Now, cases like the ECS case mean that a hospital could literally be dropped from the sky to the front lines. Sterile, protected medical gear survives the journey and can mean the difference between life and death. First, small metal cables called lanyards are clipped on. These serve as the lid's hinges. Next, a hole is routed and trimmed for the pressure relief valve. This helps to depressurize the case during air transport. Then, the case is handed off to a second workspace where the latches are mounted. Now that the case is assembled, glue is applied to the slot along the edge and fitted with waterproof rubber stripping. Then, the case is submerged to make sure the seal holds. Once it passes the water test, the case is packaged up and prepped for shipping out. No matter what the cargo, at this plant, there's a strong case to be made for it. Coming up on Battle Factory, a how-to guide to putting a roof over your head, and a half-ton pickup that morphs into a super truck. For a downed pilot or a soldier caught in hostile territory, the key to survival is rest and shelter. Elite forces have created training exercises that teach the soldier to build an A-frame shelter that both protects him from the elements and hides him from the enemy. The A-frame shelter breaks down into the frame, the roof, and the camouflage. But before starting on construction, you've got to find the right location. When scouting a location to build a shelter, look for natural camouflage, like a clearing surrounded by a dense thicket of trees, with plenty of fallen branches, twigs, and leaves to use as construction material. The ground should be level so the structure will be stable, and so water will drain away from the shelter. The optimal site would be hidden from view, but still have access to water and food in the form of edible vegetation like berries or mushrooms, and bugs for a crunchy protein snack. The first thing to consider is the size of the shelter. It's got to be long enough to provide cover from head to toe. An operative will lie down to mark the length with sticks. Bedding comes first. The shelter is built around it so the frame isn't toppled over while trying to get the bedding in. Tree bark and fir branches create a soft, comfortable surface that separates the body from the ground to keep cold and damp out. More body heat is lost to the ground than to open air. The A-frame is made of 3 strong branches. The arms, which are made of 2 pieces of equal length, support a spine called a center pole, which runs lengthwise from the arms down to the ground. If they can be found, arms with forks at one end are best for supporting the center pole. The length of the arms determines the height of the shelter. Lower shelters do a better job of retaining body heat, but limit maneuverability inside. Flexible cedar branches act as a natural twine to tie the arms together. On June 2nd, 1995, fighter pilot Scott O'Grady was shot down over Bosnia, forcing him to parachute into hostile and desolate forest. Without food or water, O'Grady knew he had to keep out of sight and stay alive until help arrived. He'd have to rely on his survival training. By day, he slept in shelters built with whatever he could find on the forest floor. He traveled by night to avoid detection. Subsisting on plants, bugs, and rainwater he collected in a sponge, O'Grady managed to survive and evade capture for 6 nights before being rescued by the Marines. First, the woods are foraged to collect branches of increasing height to line up with the angle of the central pole. If need be, the branches can be snapped into size or cut with a pocket knife. The roof is constructed by leaning branches against the central pole a few inches apart in order to form slats. Once the slats are complete, young leafy branches are threaded through and piled on to create a weatherproof thatched roof. This thatched roof will keep out wind, rain, and snow while trapping body heat inside the shelter. For a soldier stuck behind enemy lines, survival also means avoiding discovery and capture. So the shelter is draped in natural camouflage made of fallen leaves. It might not be the best night of sleep he's ever going to get, but the survival shelter means the soldier can stay warm, dry, and alive until help arrives. Coming up on Battle Factory, a bulletproof troop carrier that keeps rolling under fire. Take a standard pickup, strip it down, and build it up with ballistic steel, and an ordinary truck becomes a bulletproof fortress on wheels. The Incas Armored Personnel Carrier is speedy, agile, and bulletproof. It can transport up to 10 troops or police in and out of hostile territory at 90 kilometers per hour and keep them safe even under high-caliber weapons assaults. World War I saw the advent of the Armored Personnel Carrier, the Mark IX, which was first deployed to the Western Front to safely carry infantry accompanying tanks past enemy lines. Now troops could be transported in larger numbers and dropped directly into combat. While production started in September 1917, only 3 of the Mark IXs were made in time before the war ended in 1918. Even though there were only a small number of APCs produced, they forever changed the way battles would be fought. The Incas Armored Personnel Carrier breaks down into the frame, the chassis, and the armor. The Incas Armored Personnel Carrier starts out as a stock Ford F-550 Super Duty truck. The transformation begins by stripping the truck, tearing it down until all that's left is the chassis, a bare metal frame, and the engine sitting on 4 wheels. Now, it's ready to be rebuilt from the ground up. The chassis is reinforced with mild steel, so it can withstand hard riding without cracking. And the brakes and suspensions are tricked out so they can handle heavy armor over rough terrain. The next step is to add the armor, which creates a virtually impenetrable shell able to withstand explosions and enemy assault. But before it can be added, the ballistic steel, called B6, has to be tested. 1 sample square from each batch is pulled, and 3 rounds are fired into the same spot. If none of the bullets pass through the steel, it's considered ready for use. If the metal fails the test, the entire roll is trashed. The bulletproof metal is put into production, and the armor plating can begin. Shapes are carved out with a laser, including the windows and gun turrets. Next, the armor is bent into shape on a 10-ton press. Ballistic steel is also used to fully encase the vehicle's engine in a bulletproof cage so it can keep running under fire. By the onset of the Second World War, both sides realized the necessity of mobile command and control in wartime. As a result, APCs were produced and employed by both the Axis and the Allies in much larger numbers than before. And the carriers evolved from simple armored cars to the ultimate in sophisticated engineering and highly effective tools of war. Today, they're an indispensable asset for armies around the world. The APC's frame is made from mild steel. Its low carbon content means the metal will flex instead of cracking under the impact of a bumpy ride or bomb attack. The steel floor fortifies the chassis against landmines. The outer frame is assembled, lowered onto the chassis, and welded together. A layer of foam insulation is sandwiched between the steel plates to protect the passengers from harsh weather, as well as providing another anti-ballistic layer. The B6 ballistic metal is then welded to the inside of the hull, making it completely bulletproof. A projectile would need to puncture the mild steel, pass through the foam insulation, and penetrate the ballistic steel in order to hit and harm the vehicle's occupants. Nearly impossible. Once the truck has been coated with a textured paint that forms an anti-reflective skin, work is done on installing the bulletproof windows, the seats, and the dashboard. After hundreds of work hours, the armored personnel vehicle rolls off the line for a test drive, pushing it to the speed limit on the highway, then knocking it around to make sure it's off-road ready. Converting a stock pickup into an armored vehicle is like turning a mortal into a superhero. And when the transformation is complete, this monster truck is unstoppable. This time on Battle Factory, the survival kit you carry in your pocket. The red dot that's right on target. Battle dress that's bulletproof. And the submachine gun that strikes like a scorpion. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When these tiny tools are machined and joined together, they will make up the ultimate mini multitasker. Since its invention over a century ago, the iconic Swiss Army knife has evolved into a pocket-sized hardware store with fold-out features that include everything from tweezers to a wood saw. In 1891, in his cutlery shop in Eibach, Switzerland, inventor Karl Elsner came up with a multi-tool which incorporated a knife, can opener, and screwdriver in one compact body, the soldier's knife, and soon became standard issue to the Swiss Army. Today, the Swiss Army knife is used by millions of soldiers and civilians alike for everything from chopping firewood to building a spear. The Swiss Army knife breaks down into three parts: the case, the dividers, and the tools. All the steel tools are made with 13% chrome to make them rust resistant. Before construction begins, the steel sheets are checked for consistency. A spectral analyzer measures the purity of the metal. Spools of 3mm thick steel are transferred to the punch press room. 20 computer-controlled presses punch through the steel with 40 tons of force to cut out the Swiss Army knife's legendary blade. Each strip of steel will produce 30,000 knives. Next, the bottle openers, can openers, and the rest of the Swiss Army knife's many gadgets are punched out. The classic model contains 7 tools, including the penknife and scissors. But some knives, like the Swiss Champ XXLT, have 70 gadgets, including pliers, a magnifying glass, and a ballpoint pen. The blades are placed in huge vibrating machines filled with stones and rubber chunks, which grind against the blades to deburr or smooth the edges. Then the blades stick to a magnetic wheel, which picks them up and drops them onto a conveyor belt. They're deposited into a rotating tank full of sand, where they're dried and degreased. The excess parts are shaken loose in a jitter machine. The knives and other pieces are heated and then rapidly cooled. This alters their molecular structure and hardens the metal. Next, the parts are transferred to the automatic shape machine. The grooves, angles, and inserts are machined into the metal blade and can opener, which enables the user to grasp the tool between their fingers and pull it out of the case. In 1995, during his first mission into space, Canadian astronaut Chris Hadfield used his standard issue Swiss Army knife to dock the space shuttle Atlantis to the Russian space station Mir. The cosmonauts had secured the hatch with a tough triple-knotted strapping material, and Hadfield simply couldn't untie it to open the door. Unclasping the blade on his Swiss Army knife, he was able to cut the strapping, get the door open, and make history. All the parts are collected and itemized in a sorting room before they're shipped off for assembly. Pins are pressed into the case walls, which hold the entire mechanism together. Each item is placed in layers by hand. Then a machine stamps them into place. A bushing is placed in between layers so that each tool unclasps smoothly without getting stuck on its neighbor. Then the cover is press-fit on, and the little plastic toothpick is slid into its sheath. Before they leave the plant, every function on the knife is checked by hand. The Swiss Army knife is complete. Whatever the add-on, the Swiss Army knife has already earned its reputation as a legendary toolkit and a survival kit you can hold in the palm of your hand. Coming up on Battle Factory, taking aim with laser-sharp accuracy, and what to wear to the front lines. When power runs through this diode and lens, it will project a laser beam that pinpoints a target with total accuracy and plants a red dot right on the bullseye. The Crimson Trace MVF600 red dot laser sight fits on the rail of a gun, and with its built-in flashlight provides precision targeting in any environment. Red dot laser sights were invented in 1975, but they weren't adapted by the US military until the year 2000. Today, the laser sight is an integral part of the soldier's kit, sharpening aim and enhancing targeting, especially for nighttime operations. The laser sight breaks down into three main parts: the flashlight, the tang, and the laser. The laser consists of a diode, which is an electro-optic, like the little filament inside of a light bulb, and a precision lens. In order to make the laser work, two tail wires need to be attached to the end of the diode, and the lens placed on top to focus the beam. First, the diodes are steadied on a fixture, and then the brass tips are snipped off. Next, the wires are dipped in an acid solution, then soldered to the diode tip. Now wired for power, another technician presses the diode's tail post firmly in place with a coating of epoxy. The bond has to be tight for the laser to project a perfectly straight beam. Then it's left to dry for 24 hours. The lens is dropped into the lens holder. The cap goes over the holder, and the lens system is press fit together. The lens system amplifies and focuses the laser beam, which can project onto an object up to 230 meters away. Pulling off a covert operation takes exhaustive training and razor-sharp aim. An elite team might take days closing in on their objective, and then suddenly storm their way past a heavily guarded perimeter. With the laser sight pinpointing their target, that red dot will be the last thing their targets ever see. The laser and flashlight sit on opposite sides of the sight's handle. First, the flashlight's electrical system is assembled, then capped inside the casing. Then, The laser's diode and lens are fit together. Once connected, a tech calibrates the laser beam for sharpness and accuracy. The laser is then locked into its casing to complete construction. The tang contains the laser sight's power supply, housed inside the grip. Once the circuit board is programmed, it's installed alongside the batteries and controls into the handle. The tang attaches under the barrel of the weapon, doubling as a grip onto which the flashlight and laser are mounted. The on-off switch is right on the grip, so the shooter never has to take his hand off his weapon to activate the sight. The laser sight is calibrated to ensure total precision. The MVF-600 is ready for action. On the firing range, the laser sight is tested for accuracy. The beam aims for a target 30 meters away, focusing the red dot at its center. Bullseye. In the real world and combat zone, the MVF-600 will do what it's designed to do with lethal precision. Guide a bullet so it lands right on the red dot. Coming up on Battle Factory. A suit of armor for the modern-day warrior. And looking down the barrel of a submachine gun. These bolts of bulletproof fabric will soon become wearable protection and a soldier's last line of defense. In the past, body armor tended to be clunky, cumbersome, and restrictive. Today, it's built for maximum protection and maximum mobility. Fenix combat body armor owes much of its strength to a lightweight synthetic ballistic material called Aramid. Comprised of 82 different pieces, the Fenix body armor is made up of the armored plating and the fabric. Rolls of camouflage fabric are laid out onto a table. Templates of the 60 shapes that make up the vest are laid over the material, traced and cut. A layer of 3D shock protection netting lines the inside of the vest, absorbing the impact of an explosive shock wave or bullet to minimize injury. Camouflage fabric pouches are sewn into the netting that will hold padding and armor. The basic profile is then sewn together to form the front and back of the vest. Heavy nylon strips are sewn into the vest to hold the surface components of the armor in place. Layers of Aramid form the soft ballistic protection packets. They're placed in waterproof bags and sealed with an ultrasonic welder before they're inserted into the vest. This process is vital, as any water or moisture in the Aramid will compromise its bulletproof nature and make it act more like a lubricant, actually helping the bullet to penetrate the wearer. In a Taliban compound in Afghanistan in February 2008, Royal Marine Corporal Matthew Croucher was patrolling with his crew when he hit a tripwire tied to a grenade. With only seconds to react, Croucher threw his backpack onto the grenade and dove onto it, hoping his sacrifice would save the rest of his team. While the explosion tore up his gear, his body armor absorbed enough of the impact to save every member of his unit, himself included. Croucher was awarded the George Cross for gallantry. The rigid armor is made from plates of strong, lightweight PVC. The smaller segments are die-punched by machine, but larger pieces, like the backplate, are traced, cut, then punched out by hand. Holes are punched out of the PVC plates to lighten the armor. The plates are then sewn into the pouches in the front, back, shoulders, and around the waist. When the vest is tightened, 35 kilos worth of armor plating is spread evenly around the body, taking the stress off the shoulders. Now, the body armor is ready to be assembled. The packets of Aramid are inserted into the camouflage fabric, and the 3D shock protection pouches are sealed with Velcro. An additional layer of heavy ballistic material is inserted into the body of the vest. The front and back pieces of the vest are attached to a quick release system, so they can be ripped off to alleviate weight or treat an injury. Then the groin, shoulder, neck, and other padding is attached to the main body. The completed armor is ready for testing. On the firing range, the body armor is draped over a thick block of putty to simulate a human body. First, it takes rounds from a semi-automatic 9mm. Then the armor is checked to see where the bullets might have penetrated. Marks in the putty would be wounds on the wearer. Then the process is repeated with a submachine gun. If the armor survives the test, it will be shipped out to Special Forces units, who will custom kit them to their personal specs when they wear them in the field. And the next time bullets are fired at this armor, it will be protecting flesh and blood. Body armor won't make the wearer invulnerable, but this protective gear can get in the way of a bullet and keep a soldier alive. Coming up on Battle Factory. A single round or full-on automatic, it's the right weapon for any operation. When this steel pipe is drilled and honed, it'll become the barrel end of a weapon that's compact, versatile, and deadly as a scorpion. The Scorpion submachine gun is lighter than a rifle and more versatile than a handgun. Fast loading with a fold-out stock, it can fire single shots, 3-round bursts, or empty its magazine in full auto. Accurate to 200 meters, the Scorpion is the weapon of choice for many military and security forces around the world. And the Scorpion machine gun's ability to shoot with precision is built right into the barrel. The steel used to make the Scorpion's barrel is first left to cure outside the plant. Weathering the rain, heat, and changing temperatures might coat the metal with rust, but it also makes it more durable. First, the barrel is precision drilled to create a hollow running the length of the cylinder. Next, the opening is bored out in 115mm sections. The barrel spins on a lathe to scrape off the rust and smooth out the surface. In a hammer forge, 4 synchronized hammers pummel at the steel 1,000 times per minute with 45 tons of force, extending the length of the barrel and etching out corkscrew grooves on the inner wall. These unique grooves, or rifling, cause the bullets to spin so they fly straight and true. Then, the barrel is cut to length. Finally, a technician inspects the barrel's interior, cleaning out any debris and checking the rifling that makes up this Scorpion's distinctive fingerprint. Any flaw in the barrel could send a bullet way off its mark. The trigger is cut to spec inside a computer-controlled cutting machine. Small components that make up the submachine gun's action, including the slide stop, trigger, and dynamic bolt, are baked in a very hot kiln to harden and toughen the metal. On April 30th, 1980, 6 armed men stormed the Iranian embassy in London, taking 26 hostages and demanding passage out of England and the release of their imprisoned brethren. For days, British police stalled, managing to gain the release of 5 hostages without giving in to terrorist demands. In frustration, the terrorists executed a hostage. With lightning force, the British Special Air Services, armed with submachine guns and stun grenades, stormed the embassy, killing 5 of the 6 terrorists and rescuing all but 1 of the hostages. The SAS solidified their reputation in the most successful rescue op of all time. All in all, it takes about 25 minutes to assemble the gun. Each part must fit precisely to within a millimeter's tolerance. The barrel is attached to the body of the gun. Next, the trigger assembly and slide are inserted into the stock. The Scorpion submachine gun is known as the gun that'll shoot under any condition. To make sure it lives up to its rep, testing goes to extremes. First, the gun fires 2 overpressure rounds, 20 to 30% more powerful than a typical round, to ensure the strength of the gun. Then, the gun is subjected to a 5-round precision test, the results of which are measured by a computer. The Scorpion is built to withstand being dropped from a height without shattering. It can also be submerged until water fills the gun. Once it's completely soaked, rounds can still be fired in full automatic mode. Even when the gun is dumped into thick bogs of mud and coated, it continues to fire. The Scorpion submachine gun combines the best of a full-scale automatic rifle and a nimble handgun. And like its namesake, it's got survival skills and a killer instinct.